And get going. So this is AWS CDK Beyond the Introduction. My name is Jason Butts. I'm a solution architect and practice lead of the DMI. Thanks everyone for coming here today. On the slide are social media links and such. I'm not on Twitter. I like Mastodon better. So join the Fediverse. So this talk is going to be, it's inspired really by a lot of the things I've seen newer users to the CDK do and where they went wrong and what they needed to do to take and really go beyond that introductory initial use case and start taking it to next level and more advanced usage of the CDK. So even though this is beyond the introduction, I am going to give a really quick intro to the CDK. The CDK allows you to define your resources for the cloud using different programming languages instead of using YAML. Instead of a couple thousand line configuration file, you actually use code, you get if statements and everything. Those cloud resources are modeled as constructs that encapsulate one or more different resources into what are hopefully going to be reusable objects. It allows you to abstract away a lot of the complex configuration and streamline the definition of your resources. So first thing to do to go beyond the introduction is don't put everything in the constructor. The CDK is made up of different kinds of constructs, and you can use those to break down your application, your framework, into a collection of resources. I have seen 2,000 line long constructors. It was hard to maintain anything. And sometimes you can't avoid some of it. If you're working with API gateway and you have a lot of different Lambda functions and different endpoints, things are going to get a little long. But maybe that API gateway should be its own constructor. That way you're not having to see that every time you go in to do anything. Keeping on that theme of constructs, you want to make sure you're using L3 constructs. Within the CDK, L1 constructs are the low-level, almost identical to CloudFormation objects. The L2 constructs are going to be intent-based, and they are wrapping aspects of permissions of aspects of configuration, and put it into a single object. If you're used to working with Lambda, for example, that function construct that you're using over and over, that is an L2 construct. L3 constructs are meant to hold patterns, and defining your own patterns is a way that you're able to abstract away the configuration. You're able to more easily test what you've built, and you are keeps it all cleaner. It makes it a lot easier to maintain everything, and you don't have to write all of these patterns yourself. AWS Solution Constructs is a collection that has a lot of common patterns that are already pre-built that you can make use of. For example, a lot of times if you're working with CloudFront and S3, you're going to be connecting the two, you're pulling static resources out. They already have a construct for that. You're able, yes.
Oh, sorry, you have this microphone. I want to make sure that's
okay.
These walls are glass, and I don't want, if it's too loud, just.
Gotcha.
Sorry.
All right. So like with S3 and CloudFront, you're going to be connecting the two. You're doing the same sorts of things over and over again. And with that solution construct, it's already been built, put together, wired together using well-architected principles. You're not having to do all of that security configuration. You're just providing an S3 bucket name, maybe some other aspects, and then it's wiring all the rest of it together in a single construct. With the CDK, you can have one app and multiple stacks all grouped together. Within the CDK, you're always defining that CDK app. If you're using TypeScript, it's that, and the generators, it's that file in the bin directory. That's where it is. That's where you're defining all of the different stacks that actually can be deployed out. You can have more than one stack in there. And sometimes that is a matter of maybe you need different deployment requirements. If you are dealing with CloudFront and certificates, you may need things in US East 2 or US East 1, where the rest of your app is maybe in US East 2 or US West 1. You can also use that to differentiate things out for your different deployment environments, your dev environment, your test environment, staging, prod. You can have a separate stack configuration there with the same stack construct, but with the different configuration values outlined. It can save you a little bit from some of the configuration nightmares you can get into. One pattern I've seen is people will define they'll call it like an environments file, and it's just a giant file that is all the different configuration values. What domain name do they need? Do they need to be using? What is the service discovery name? What are the different APIs that they need to hit for the different environments? Instead of having that on a separate file, you can build that in, and within that, I don't even know within that file in that bin directory, you're able to define all of those separate stacks, and it makes it a little bit easier to work with. One of the other things you can do with multiple stacks is separate out your resources. If you've used the CDK, you've probably gone through the nightmare of, okay, I need to upgrade the version of CDK packages, or I need to upgrade my database. And you're checking and checking again to make sure that you don't accidentally delete that production database. That is a nightmare I've been through, and we managed not to. The better way to do it is to separate out your stateful and non-stateful resources. Put that stateful database in a separate stack, and you can apply termination protection to that stack, and you can make sure that that database cannot be stopped. It cannot be shut down, and it cannot be deleted. Let's see. So I mentioned the deployments example. Here is a streamlined and simplified example of that. In this case, everything's going to the same region, 2 different accounts. We have different host names that we're needing to use with this sample application. And we can customize those each for the different deployment environment we have. With the CDK CLI tool, you're able to specify the name of the stack that you want deployed. And as an extra tip, it supports wildcards. So if you end up where you have 3 production stacks, 3 staging stacks, you can deploy staging, put a wildcard there, and not have to go through and list out every single stack name. Another example that I've run into is my own website. After the December 2021 AWS outage, I thought it'd be fun to make my website, my personal website, more redundant. And that means multi-region setup, making sure that it can automatically fail between S3 buckets. Everything's static, but I have 3 different regions that I'm working with. And so I was able to split things out within the same CDK application into those 3 separate stacks so that I can deploy the resources that have to be in US East 1 to US East 1. I can deploy my primary resources to US East 2, and I can deploy the failover to US West 2. One of the things I was also able to do there is develop a redundant CDN L3 construct for myself. That enabled me to take all of my CloudFront configuration, all of the security headers, all of everything you need to set up, within CloudFront with the redundant or with the failover distribution and put that in a single construct. That has made the rest of the files so much cleaner, so much easier to maintain, and so much easier to work with. With the CDK, you're also working with object-oriented concepts. So within this example, my base S3 bucket, the configuration for US East 2 and US East or US West 2 is identical. There's no difference in their base configuration. So I defined a CDK stack class that handles that. But then for my primary region, I need to set up replication. So I was able to actually extend that base stack that defines those S3 buckets. And my primary region is extending that base stack. And I'm able to layer on top of that the replication that I need. That way I can have everything get uploaded in one region and automatically move to a copy to another. So using multiple stacks and L3 constructs, you can build out your application with more complex configurations while still keeping it easy to modify, easy to maintain, and easy to work with. So automated testing is another piece to level up your CDK usage. I'm not saying test all of your CDK, all of your resources. If you're not careful, you're going to end up more or less having two copies of your code. You're going to have the test version and you're going to have your live version. And there's really not going to be much difference, or your test version is just going to look like CloudFormation scripts. That's not really where you're getting the benefit. But where you are getting the benefit is with those L3 constructs or with those complex configurations where you're standing up something like a shared infrastructure. You can unit test that specific construct, that specific stack, and make sure that that configuration has the values that you need. With Jest and TypeScript, you're also able to use snapshotting. Snapshotting is a wonderful feature of Jest, especially for front-end development, but you can also use that with the CDK. In instances where you're deploying a shared infrastructure that is going to be used by a variety of applications, any change there is high risk. And with the snapshotting with Jest, you're able to actually version control what that should look like in addition to your code. And you have to accept those changes every time you run your unit testing. When used responsibly, it is a good extra layer of safety. But if you start applying it everywhere, your developers are just going to skip any pre-commit checks, or they're just going to change the script where it's going to automatically accept all of the changes. Let's be honest, I've been there, I've done that. Takes too long to run the pre-commit checks. No, I'll run it myself when I need them. So let's see. For an example of good unit testing, let's say we have a custom CDK construct that for a Lambda we're wanting to reduce our IAM role usage within AWS or within our AWS account. So we want to reuse this IAM role because maybe all of our Lambdas need the exact same permissions. By default, the CDK function construct is going to create a new IAM role every single time. And you can pass the same value in every single time, or you can build a construct that does it for you. And we can have it set up where if that role doesn't exist, it can define it. If it already exists, it'll just automatically start using that when we use our custom construct. So you can define a test, and in that test, maybe you define 2 Lambdas, and you make sure that the IAM role is only defined once. You define another test, again, define 2 Lambdas, and maybe you define a Lambda that should be using this reusable role and another one that shouldn't, and you confirm that. You don't need to go through and define Is my Lambda referencing the right handler? Does my function have the right name? If you're extending the function construct, you can take some of that as already given. So it's a matter of focusing down where you're actually putting your testing effort. And this is not somewhere where you're really going to want 100% code coverage. So CDK pipelines are another place where you can level up your AWS usage or your CDK usage. But they're not right for every use case. So if you are looking at them, make sure that you do a lot of investigation. If you're doing true continuous deployment, they're great. Take a look at them. If you're in an environment where there's a lot of manual touch points, maybe you need a lot of sign off from product owners or somebody else before you can deploy, maybe you don't want to look at them as much. You're able to, or I guess they have constructs for CDK pipelines for both AWS Code Pipeline as well as GitHub workflows. And that is experimental, but it works very well. They do a good job of making sure that the deployments are effective, and it reduces the number of things that you have to deploy and define yourself separately. You're able to define and maintain your pipeline right alongside the rest of your application. So like I said, if you have a lot of approvals or slow approvals or complicated environment management, use caution, look at something else. But if you have one of those quicker moving environments, take a look at CDK pipelines. Now, this last one is straight out of AWS, the best practices for the CDK. Whenever you're developing with the CDK, you want to avoid non-deterministic behavior. Basically, if you give your CDK resources the same input, you want to always get the same output. You want to avoid anything that is going to change that or outside of your control. So when you're running that synthesis, you don't want to be going out and getting resources out of your cloud and running lookup queries. You don't want to be querying your internal secrets management if you can help it. You want to minimize the outside impacts to your deployments. One piece of this is, for example, if you're using the VPC from lookup, that is a special static method that it does actually do that lookup of what is in your AWS account. But it takes that and it will cache that in the CDK context file. And what that CDK context file is, it builds out an account region specific pairing of resource information of what your account looks like at that given time. And as long as you have that file and you have that file committed, it will always go through and look up that, from that file first. So if you're looking at doing this in your environment, run that synthesis on your machine for each environment. That way you get everything cached. And that way you know that AWS isn't having to go and dynamically look up those values. One of the trade-offs with that is if something in your environment does change, you have to do manual effort in order to ensure that that context file gets updated and starts using the right values. If you don't do that, it's not going to work. So if you have, maybe shared infrastructure and an infrastructure team that maybe feels like cowboys every once in a while, use with some caution. There are other ways you can get value, you can pull values into your stack. But if you do have that stability, or you are the one in control, it's going to help speed up those lookups, help speed up the your deployment, and it's going to help prevent those unexpected deployment failures. So as a quick review, don't put everything in the constructor. break it out, use constructs, and separate things into smaller pieces. Develop your own L3 constructs. Build your own patterns, reuse them within your application, and if you're reusing them within application after application, maybe create your own internal shared library. Within your CDK application, use multiple stacks. Break things down how you need, and you don't have to separate it out into all of these different repositories. When appropriate, unit test your resources. Make sure that you are deploying and defining what you think you are when it really matters. Look at the CDK pipelines if your environment supports it, and make sure to avoid non-deterministic behavior. That's all I have. This QR code will take you to a page on my website where all of these links are available. I believe they're also going to be sharing out the slides. Hopefully all the links work for that, for there, but that is all I have. Are there any questions? Yes.
What are your thoughts on naming things?
Naming things yourself versus CDK naming things. There are times where you should name things yourself, but most of the time, let CDK, let CloudFormation handle it. Your stack names for CloudFormation are always going, or they have to be unique. And CloudFormation and the CDK will make sure that those resource names are unique within your account and your region, et cetera, as necessary. If it's something where you need this value elsewhere, for example, if you're deploying an IAM role or a permission boundary that needs to be used across your account, giving it a nice name is not such a bad idea. But you also have to be careful on the resources that you give names, because if they're not able to, or I guess it depends. Some operations, when you're deploying resources, will need to replace that resource. And if you're defining that name, it's not able to do that as effectively or at all, depending upon exactly what you're deploying. So most of the time, let CDK and CloudFormation name it. Does that help? Or does that kind of work? Do you agree? Do you disagree?
No,
Okay. You're just testing. Fair enough. Any other questions? Comments, burning desires? Yes.
So in AWS,
All right. Trying to think how to summarize that question. So I guess talking a little bit more about the CDK and defining different environments and different, and how well it handles that. I showed that you can do that with having separate stacks defined with each different configuration value. You can also have a single stack in that file, and you pass in environment variables to work with some of those dynamic values. One of the clients I work with, they do that very extensively for about a quarter of their configuration. The rest of it's hard-coded, and it works very well. One of the key things, especially if you're looking to have a single stack defined and deploy it to multiple environments, is to be sure that that's one of those cases where you might want to consider actually naming the CloudFormation stack and using environment variables there to make sure you get different stack names. The client that I'm thinking of, they have the test and staging environments are the same AWS account, whereas production and development are separate. And so resource conflicts is something that we've always had to be very careful of. Does that kind of get to what you were going for? Okay. All right. Are there any other questions?
Or just introductions. My name is Steve Sini. I'm with a firm called Rigo Consulting. That's a project management consulting firm.
And I'm Sushant Mangalore. I'm a solutions architect at AWS.
What we're going to talk about today is we're going to just lead you through the story and the benefits that we've had with using Control Tower to manage a fairly large and complex organization that we had to bring up very quickly. 150. It's a SaaS application of a monolithic application, and each we've intentionally deployed it so that each one is in its own unique account for security purposes and also to make it more deployable. So Rigo Consulting. So Rigo Consulting is historically a boutique project management consulting firm. We have under 500 employees. We vary depending on our activities. We started in 2007. Up until shortly before COVID, our entire focus was on IT project management consulting and helping clients with a few specific applications like Broadcom's Clarity, ServiceNow, some other types of applications like that. Right as we went into COVID, we had an opportunity to acquire or manage half of a SaaS application. That's about 150 clients as a data center was being closed down. And that's where we started our SaaS journey. The key thing about that was there was a hard end date that was being driven by an Oracle expiration, and we had to end it on October 30th, and the contract wasn't really signed until June. So we had to move very rapidly.
So we'll talk more about Rigo's journey with AWS Control Tower, but I just want to set the table here. How many of you are familiar with Control Tower? You know what it's used for, are already using it? Just raise your hands. Okay. And if you're using AWS already, how many of you follow like a multi-account strategy versus a single guard account, as I like to call it? Okay. All right. So let's talk about Control Tower. So why this came to be, this service, it I think has been around for about 2 or 3 years now. But the reason for this stemmed from the fact that there were a lot of guard accounts that existed in different customers' environments. So one account packed everything into it. And the challenges that came with that is we're not able to do proper cost attribution for different workloads. You are running into account limits from time to time. Your security and everything else, your production, non-production was mixed up. So there were a lot of challenges with operating in that manner. And we started to recommend to our customers that you should really be using a multi-account strategy. It doesn't cost you anything extra to have multiple accounts. You get a bill for this account, you get a bill for this account. You could have a common payer account. You can roll everything up to that. So it made a lot of sense. But what then started to happen is that these accounts started to go out of parity or compliance. So maybe the security controls were tight on one account, it was not so tight on the other account. Maybe certain services were turned on here, but not here. So you wanted some kind of a governance mechanism when the account sprawl started to happen. So that's where we started promoting the concept of a landing zone. So a landing zone, as you can think of, like a real landing zone for an airplane or something like that, it's where your workloads land and they're just going to work, right? So we have this idea of a well-architected framework, and a landing zone is what we call a well-architected multi-account setup. So if you do it right, it's just going to do the right things for you, and it's going to work out of the box for all the things that you need. But the landing zone, the initial rollout of that was actually just a mismatch of different services cobbled together. So config, CloudTrail, IAM, all of that came together and you had a landing zone. And this was something that our professional services and some of our partners used to come and set up for different customers. So we wanted to make it more self-service. And that's where AWS Control Tower became a service. So now, I think there's another slide where we just talk about how easy it is. But what you do is, with the click of a button, you have to provide two additional email addresses and the email address for your management account, and you get all of these things. So you get a landing zone, you get centralized identity access, you get controls, previously called guardrails. I'm sure some of you are familiar with that term, and automated compliance, compliant account provisioning, or what we call account factory. And this is something that once you set up, you can continuously manage as well. So these are the things that come, and there's no coding or any other heavy lift required to turn this on. Like I said, it's a click of a button, takes about an hour or less at the first attempt when you set this up, but it turns on a whole bunch of things for you, but then you can just go and start provisioning your workloads into. So like I mentioned, the automated landing zone, the account factory, the guardrails, you get a dashboard where you see your compliance and how your accounts are either measuring up well to the compliance standards that you have established, or if they're out of compliance, they'll show you a red indicator that, hey, we are out of, this account is out of compliance. Maybe there's something you need to take care of. We have automated log centralization, which is one of the best practices because each one of your accounts are creating logs, and each time it creates that, you want to a central place to view it. Similarly, if you have security services turned on in different accounts, you want all of that to go to a central place as well. So all of that becomes a lot easier with Control Tower. And at the end of the whole turning on of Control Tower, this is what you get. So you get a management account, or what you call, previously we used to refer to it as master payer, but we don't call that a master payer anymore. We call it the management account. And making use of all these other peripheral services like CloudFormation stack sets, service catalog, which helps with the account factory, AWS organizations, which I'll talk about later, IAM Identity Center for centralized identity management. And you also get these two base accounts, which are the log archive account for centralizing your CloudTrail and config logs. And you get the audit account, which allows you the ability to centrally audit all the other accounts that are part of your organization. Plus you get the config aggregator, which will allow you to look at all the resources from across your accounts through a central place. And in this section, you get a bunch of provisioned accounts. And you don't get that from the start. This is something that you need to create. But you can create as many of these, and you can organize these by organizational units. So organizational units are logical groupings of AWS accounts, which you can uniformly control through different compliance mechanisms. So I'll pause there and I'll let Steve talk about Control Tower, Rico's journey with Control Tower. What were some of the unique challenges that they had, and how Control Tower helped them solve it? And then I'll go into some of the best practices with Control Tower.
So, sorry, let's go back one. There we go. Come on. Okay, so again, with our journey, what we had a business opportunity where we could take over a SaaS application. We had about 150 clients that were going to be that opportunity. We had a hard stop. They had to move on October 31st, and we were starting this transition. We started it back in March, but we actually didn't have a contract to do this until the end of June. Okay, so we had to move really quickly. And at the same time, we knew that architecturally, we needed to put each client in their own account. Okay, and that's a really great way to do it if you're, especially if you're running a SaaS application and you don't have you have an old monolithic application, because you can isolate everything. Okay, it's also great from a costing perspective, from an audit perspective. One of our clients is Her Majesty's Royal Customs. They want to come in and audit their account. It's the IRS for the UK is one of my clients. Okay, so we actually can give their auditing firm access to their account and say, when you want to come in and audit their account, you can come in, and they're walled off logically from the rest of our organization. So there's lots of great reasons to do this. Okay, so our first challenge was, the only thing I'd ever run on AWS was a bunch of stuff that we set up manually. We'd never used the CDK. We'd never used its CLI. Nothing was automated. It was just manual stuff. So we had to figure out how we could rapidly deploy this. Okay, not just stand up the infrastructure, pick up and lift and shift their databases, move them in, make the changes that we had to do, and integrate them into ours. We had a lean operations team. We hired a consulting firm. They said we needed 50 people to run this globally. The owner of our company, we're a family-owned company. He said, I can give you 20, right? And then throughout the negotiations, he said, I could get you down to 13, right? Well, I run it on 7. We have 7 FTEs that run a $10 million business that have 150 accounts with about 600 databases. Okay, globally, that we also offer 3rd-tier support in that group. So through this automation, through Control Tower and the other automations that we've been able to do with this, we run really lean and really cheap. I mentioned we had a hard project end date. If we slip back up October 31st, the Oracle licenses were expiring. There was no slip on this thing. Once they expired, business was gone. We ended up having to have 150 or more AWS accounts. We were right on the bleeding edge of the custom Control Tower framework. Okay, so the out-of-the-box solution didn't work for us. There's a custom framework. I mean, we were right on the bleeding edge of that. In fact, one of my humorous things is I keep, for the next couple of years, things that kept dropping into Control Tower were things that we created tickets on because we couldn't figure out how to do, right? And it's kind of neat. You see AWS respond to that, but for us, we're behind. And I've mentioned before, we had the hard closure end date, okay? The lessons learned that we had as we look back, Control Tower has come a long way since then. But one thing is keep current on your Control Tower continually. If there's a new version of Control Tower or the custom framework that comes out, we update it within a couple of weeks. As soon as we're satisfied, there's no major defects, but we roll it out. That helps you really keep things on top. We implement all controls by default. Now, organizationally, our structures are laid out regionally. So, we have, we support the UK, we support Europe, we support Australia, okay, and the Pacific Rim, Japan, Latin America, Canada, and the US. So ideally, we would support every guardrail or every Control Tower, kind of security feature, right, or limitation on our, automatically. But there's some you can't do. And there may be some that you need to do in Europe that you don't have to do in the UK. So really go crazy. Our default policy is we deploy a guardrail no matter what. That's really helped with auditing. And by the way, for those of you that go through SOC audits and FIPS audits, this is great. Okay, this is like a great tool because you now can lay everything out. Automate account and resource provisioning. This was pretty crude when we started. It would take several hours to deploy an account. We had to do them one at a time. We had 150. Luckily, it was during COVID, so none of us were leaving our basements. We pretty much had to run things 24/7. This has gotten a lot better, and there's even more frameworks now that you can leverage. I can't think of the term, but you can actually have it. You can set more of a default environment that will come in and pull in your stacks that you want to pull in automatically. Centralized security tooling. This is a huge benefit for us. So what we did with Control Tower was we also went along and we deployed Security Hub and all of the AWS core security services. So when we stand up an account, all these are set up by default, right? We can't forget about them. When we get audited, I don't have to look back through and say, well, why didn't employ guardrail in this account? Or why is Macy not running in this account, right? Everything comes in and it's there, it's centralized. It's in an audit account, so it's really easy for you to say only a handful or a subset of people on your DevOps team have access to that account, okay? We use IAM for SSO. We integrate with Microsoft SSO. That's worked seamlessly for us. When an account is created, the right groups are there. If we need a special group, we can drop it in. That's also nice. We're a small company, and that lets me have a layer of separation between my IT group that controls who's in each account and who's in each group, right? I don't have that. I have to open a ticket for that. That gives me traceability for my auditing, right? And I just have to apply which groups go to which accounts. So from an auditing perspective, if you have to deal with SOC audit, that handoff is usually pretty important. We utilize lifecycle events and organization events. We also utilize Security Hub events to automatically, again, we only have 7 of us globally. So we're trying to automate everything we can. The other things that come out of this, if you're using the AWS pieces, is it's really easy to automate and monitor patching. So we've had to go through and audit or upgrade almost 1,000 Oracle databases at once on a weekend. And because we're so consistent and we use everything with stacks, we start with Security Hub or with the Control Tower as our framework, we can easily go through and patch our EC2 instances, patch our RDS instances, and produce reports for auditors that say, all of our EC2 instances and all of our Lambda instances are 100% patch compliant in the last 45 days. And then the last thing is the audit account that it sets up gives you a great place to monitor and maintain security, that you're totally isolated and walled off. So you can have a security team, or a security person on your team that only has access to that account. So with a logging account, you can just wall that off separately. So
Right. So what do you have to do if you want to turn on security or control tower today? And what are some of the best practices that you want to follow? Let's talk about that. So like I said before, this is what you get out of the box. You get the payer account, log archive, audit account. Your audit account can usually double up as your security account as well. So that becomes like your delegated admin for security services such as Security Hub. So if a security issue is found in one of the provisioned accounts, sends that finding over to the audit account. So the security team has to go to just one central place to look at all the findings. Similarly, there are other services like Guard Duty, IAM Access Analyzer, Macy, all of the ones that allow delegated admin functionality. You can make your audit account the one place. The other thing is the security cross-account roles. Not many understand this very well. I had authored a blog about this, but what this allows you to do is, this comes with two roles. One is a read-only role and one is admin role, which has access to all the other accounts that you provision inside your control tower. And that those roles can only be assumed by a Lambda function. So you can spin up Lambda functions here, which can go across your different accounts in the control tower and do pretty much anything that a Lambda function can do. So if you want to check how many EBS volumes I have that are on GP2 that I can maybe migrate to GP3, or how many Route 53 hosted zones do I have across different accounts. So all of that, you can just simply spin up a Lambda function and it can go do that for you. All right, now let's talk about how do you organize your OUs and what are some of the recommended OUs that we've seen customers implement and be very successful with. So the sandbox OU, if you have a large development team and you want to allow them to experiment, that's where the developer accounts go. Every developer gets their own account. You can put budget controls on that they do not exceed more than a few $100 or few $1,000 every month. Within that, they can use any services they want, experiment, innovate, do whatever they need to do to bring more ideas to your business. Workload-specific accounts, those are, I always recommend segregating by workloads first and then by life cycles. I've seen customers do prod OU versus non-prod OU, but not all your production workloads are going to be the same. Not all your non-production workloads are going to be the same. So what you want to do is first segregate by workloads. So if you have like, I don't know, say an e-commerce application and a supply chain application, for the lack of better examples. So you'll have workloads or OUs for the e-commerce application. And within that, you'll have separate accounts for your production and non-production. So that way, most of your controls are going to remain the same because controls usually tend to be workload specific and not life cycle specific. Although your production controls have to be tighter than your non-production controls, but segregating them by workloads usually makes sense, or business applications make sense. Policy staging. Okay, we talked a little bit about controls or guardrails, but there are three variations to it. So there is the preventative guardrails, there is the detective guardrails, and now recently we introduced something called proactive guardrails. So the preventive guardrails are implemented using something called service control policies. And service control policies are things that work at a higher level than IAM, and they can deny different permissions within accounts. So even if the individual accounts have root permission or admin access, the SCPs override all that. So with SCPs, you want to be very careful too. So before you go and apply an SCP to an OU or an account, you want to test it out. So you create a separate OU just to test out your SCP changes because it can have very large scale effects. So you want to be sure exactly how it's going to behave before you apply it. Suspended OU is for accounts that if you're like running a SaaS business like Steam, you want to maybe offboard a customer. So you first move them to the suspended OU, and from there you decommission all their resources. Individual users outside of developers, if your business users say need to send some numbers from S3, you can put them their own accounts. Exceptions are accounts that do not fall under any of these other ones because they are exceptions for a reason. And you understand that you have provided some kind of security or governance exceptions to those accounts for particular business needs, and you put them in their own OU. And lastly, for things such as CI/CD or automated patching, like using systems All right. So that was a journey for a new customer. Now imagine that you already have an AWS environment, and it can feel like a big lift moving into Control Tower. And before it was even not possible to make use of your existing accounts and bring that over to Control Tower. But we have simplified all that now, and you can pretty much use your existing account. The only thing that you want to be conscious about is that for your management account, we ask that, or we recommend that it doesn't have a whole lot of workloads, because the management account is only intended to be used as the governance account. So it is only there for your billing and for applying security and SCPs on your other accounts. So keep that as lean as possible and move all your workloads into workload specific accounts, right? And then all the other things that you already have, if you're already making use of IAM Identity Center or SSO, Control Tower will latch onto that, provided you use the same home region for Control Tower. Your config, you may want to turn that off, because Control Tower turns on its own config. Same for CloudTrail. CloudTrail, before it used to set up a trail in each account individually, but now it sets up an organization trail, which applies to all of your accounts. And then those logs get centralized into your logging and archive accounts. So it's quite easy, even if you're an existing customer who are quite a few years into your AWS journey, it's still not too late to adopt Control Tower. And Control Tower doesn't cost you a cent. You're only paying for all the services that it orchestrates, like config and CloudTrail. And usually it doesn't make a dent into your bill at all, because these are all peripheral services which just provide you some security and governance that you need. All right, so this is just in summary. Control Tower is making use of AWS organizations and all the benefits that come with it. So things like centrally provisioning your accounts, sharing resources across multiple accounts, or optimize and organize your costs, and finally, integration with security services like Steve had mentioned. And some of the use cases, again, here are rapidly innovating with provisioning resources for each team. Sorry. Organizing your AWS accounts by business processes or businesses, simplifying your billing. So the best level of cost attribution that you can get on AWS is by having separate accounts. You can obviously do tagging, but you'll always forget to do tagging. And then you'll wonder, why is this costing me so much? But if you have different workloads segregated by different accounts, you can go exactly look at, this account is costing me this much. My e-commerce application is costing me this much to run every month. And this is how much I'm making in revenue from spending that much. So you get the perfect show back or charge back for every application. Lastly, for implementing all these different functionalities, these are the services that we make use of internally. So like I said at the start, Landing Zone orchestrated a bunch of services, but you could actually see them. With Control Tower, you don't see them unless you want to go see them. So it happens under the tower. It makes use of CloudFormation. It makes use of Systems Manager, Service Catalog, all these other services that you see here. Systems Manager is very underappreciated. It's one of my favorite services on AWS. I call it the SRE personnel Swiss Army knife, because there's so much you can do with it. And I'm sure the 7-person operations team that Steve is able to run today is partly or largely due to combination of Control Tower and Systems Manager, because patching, the compliance check for different automations, all of that, the playbooks, runbooks, all of that can be done using Systems Manager. What else do I have? Trust Advisor, by all means, make use of it. Another free service, gives you a lot of great recommendations. And again, you can centralize all of that into your audit account and look at it from a central place. All right, that's all I really had for today. These are our email addresses. Forgot to put my LinkedIn on there, or LinkedIn, but feel free to catch us in the hallway. And if you want to connect, we can. Any questions that I can, or Steve can answer for you today? And I don't know how we're doing on time.
3 or 4 minutes. So.
Okay.
So I work in an organization that has their
Mhm.
Is there a tool or solution migrating things
So how automated is your infrastructure creation? Like, are you using IAC already, like Terraform or CloudFormation? Because then it's just a matter of spinning up into a specialized account of your own.
Not as much as we should.
Okay. So that makes it a little harder, but there are some, there is some tooling available. Have you heard of Former or something like that? Former 2. It allows you to create CloudFormation from existing spun up resources. So with that, you now have your infrastructure documented as code, and then you can use that to spin up the same resources. If you're just trying to do that by hand, it becomes a little hard. The other option is, again, running API against existing resources, getting their properties and codifying them through IAC. And then when you spin up your own specialized accounts, you can create those in the same infrastructure in those accounts as well.
So we migrate stuff.
Yeah, I mean, DMS or logical snapshotting and replication. So Control Tower, until recently, it did not even have an API. So there was just the console, which allowed you to create the initial setup. But if you're talking about specific guardrails, or for example, there are different levels of configuration for guardrails. If you're doing like a detective guardrail, that's all AWS config, right? If it's preventative, it's all SCP. So there's not one central configuration for Control Tower. It's made up of a few different levels of configuration. There's security configuration, there's the account factory configuration, and most of it is just YAML. So account factory is service catalog is CloudFormation. Any other questions?
Customer, they want to onboard the.
Mhm.
So I was doing the POC for this.
Mhm. I guess we can talk about that. The advantage that you get with Control Tower's CloudTrail is that it's automatically already centralized to send your logs to the log archive account. I don't know if you're already doing some kind of log centralization, but I think there is an option to turn it off at an organization level, but I'll have to look into that for you. But the reason we recommend an organization level and not a individual account level trail is that if you duplicate trails, it costs you more as well. So for that reason. Okay. Mm-hmm. Yes. I don't fully agree with that because we create roles with the least privilege principles in mind. There are places where admin access is required because, for example, your root account needs admin access to all the other accounts that are part of your organization. But I don't think we are creating too many admin roles that are not really required to be admin. But let's talk about that.
When I look at some of the guardrails too are preventative and they're SCPs that are sit on top of your account. So to me, the benefit there is so my master account, I got to make sure I protect that. But I think those SCPs would really protect everything. There's no console that can go on. Right? It doesn't matter what's centrally. And from an InfoSec perspective, I can walk into an audit. We've been audited out the master audit, a few months after you're stuff to that goes through the Deloitte audit client next week, and just produce the control tower stuff. If that was all separate, that's me.
But I'm curious to really know what roles they are that are over permissioned. We can talk about that and see if there are any opportunities to tweak those. Cool. All right. Thanks.
So we are welcome to this session. We're going to talk about building a portable platform. We're going to talk about what a platform is, what that means, and how you can build one with OpenShift, which actually leads me to a first question. How many people here have heard or have used OpenShift? Okay. And what about ROSA? Do people know what ROSA is? So I got one hand there. ROSA is that's the nickname, I guess, for Red Hat OpenShift on AWS. It's a first class service up there. You can go to aws.amazon.com /ROSA. I put a link at the end here. It's a great way to skip some of the initial provisioning that you got to do with OpenShift, especially if you're running it on-prem, but even if you're running it in AWS. So yeah, it actually provides, that's what we're going to discuss. It provides a great way to build a lot of stuff on top of it. So yeah, I kind of glanced over, but I work for Red Hat. I'm a solutions architect. I support customers in the Chicago area. I'm also really involved with CNCF work. I'm a leader in the tag app delivery, where we review projects, we write white papers, and we try to support end users in delivering workloads and applications on cloud native platforms. A lot Kubernetes, but also AWS, that counts. And I also wanted to mention this. We just had our first event on Monday since post-pandemic. Our first in-person event, the Chicago CNCF group. We're having a planning meeting a week from today, actually, if you want to join it. We hope to have an event in August, an in-person event. We want to run some Kubernetes community days. CNCF is pretty supportive of that. So join us. Check out the site there. Join the site. You get our emails. Come to our events. I figure it's a good place. This is the AWS community. I'm talking with Margaret about how we can work together. Okay, now let's jump into the fun stuff. So what is a platform? In Tag App Delivery, a couple of years ago, actually, we formed a group called Cooperative Delivery. That was what we called it to begin with. The goal of the group was to help our users deliver their applications and their infrastructure. Like, there had been this movement around GitOps, and we can get out a Kubernetes cluster, or we can get out databases, but how do we actually get an app and infrastructure coordinates? So I get the database and the cluster that I need together with the Spring Boot app or whatever that I need on top of it. And we pursued that group. We formed a couple of years ago, but then we realized the platform engineering movement was really coming up with an answer. Platforms is the flip side of cooperative delivery. How do we achieve cooperative delivery, including our app team and our infrastructure team, with a platform, with a shared platform that makes it easy for application delivery folks, application teams to deliver. So we renamed the group the Platforms Working Group, and we set out to write this paper. A bunch of us got together at KubeCon Detroit last October, and so we're gonna put together a definition, vendor neutral, very technical, in support of, our first goal was to support engineer architects, people that want to advocate for platform engineering within their company, how they're going to convince their director or their VP, this is going to have an ROI for our product, for our company, it's worth investing in. That's kind of what our first paper takes, that perspective, and says, here's strategically why you want to adopt this platform mentality and adopt platform engineering. We continue to work on this. So if you want to join us, we continue now, especially we're working on tactics now. We've kind of, to some degree, if you read the paper, maybe you'll be convinced. We've convinced a lot of people that it is a strategically good direction. Now they're asking us, okay, help us on this journey. What does it look like? How do I go from my classic data centers to a more platform engineering, agile environment? Anyway, one of the big things we defined, one of the big debates we had at the beginning actually was, what do we call these platforms? Literally, some people want to call it developer platform, delivery platform, DevOps platform. I saw Gartner, they just published a report this week or last week about DevOps platforms, but they used to call them value stream delivery platforms, which is very accurate, but also very arcane, and nobody knows what that means. Anyway, so we realized we're not going to be able to choose an adjective. So we just said, we're going to define what a platform is in general. Two major things. One is that we said a platform is when you're bringing together a bunch of capabilities with a consistent experience. So for example, where this comes up in cloud native computing is like, we tried to list out, but 10 different categories of capabilities that you might need to run a cloud native environment. And we're trying to point out like, hey, if you don't think about this deliberately, you're going to end up with 10 different patterns. My database, I get this way. I already open a service now ticket and talk to that guy. My IAM roles, I talk to this team. My DevOps pipelines, I talk to this team. If you don't try to put a consistent layer over the top of that, it's going to be not great for your app dev team. We also called out that it's to target a specific need. Rather than just the generic platform that can cover anything, it should be built towards the needs of, if it's application development, web app development, backend development, ML ops development. Yeah, so check out the paper. There's the slide up there. I don't have a clock here, so I want to make sure that I'm on track. You know what? Okay. I think it's important to mention this, that there's always a platform. There's always this abstraction somewhere. It's really a question of where is the right line for your organization or your environment. And it kind of takes building up, to be honest. Like, even I'll talk about here, you could build a Kubernetes platform and you could build, more layers on top of that. But I think it's relevant to say, like, from the, there's probably a bigger gap here. I skipped some, but we started out, you want to program an application, you want to program a workload, you had to have somebody go in and plug in different patch cables. Eventually that all got abstracted away by an operating system, which lets me use kind of generic hardware and reprogram it, just by writing code. So, back in the 2000s, 1990s, we had data centers full of servers, which were abstracted by the operating system. As we get into like the late 2000s, 2010s, that gets kind of abstracted, kind of the VMware, AWS EC2 era, where we're no longer really looking at our servers anymore. What are we providing to our, and I put app developers, because this is what we're delivering to app developers. So like in 2005, I was working at a company, they gave us 20 hardware servers, we run our SharePoint farm on. In 2015, they would give you 20 VMs. Or 20 EC2 instances and some buckets and virtual networks. Where we're going now is platform capabilities. Like, great, you can give me compute, storage, network. Now build a database out of them. I don't have time to do that. Build a certificate manager. This is SQS. I wrote down what each one is. Aurora. This is Rosa, actually. They have the first class icon for OpenShift. That's the Oprah OpenShift. These are different managed code build, so different managed capabilities or platform capabilities that our AWS gives. And most of the time, your app developers are not getting down to this level anymore. Maybe some. The truth is that nothing ever goes completely away. So they might still be using infrastructure also, and they might even be using servers, but a lot of use cases can be met by just giving the platform capabilities. Yeah, another topic that came up in the discussion as you're writing this paper is the term internal platforms. If you've heard, who here is sort of internal developer platforms? That term has been making the rounds, the past year or so. And we wanted to be really deliberate, like, why are we calling it a developer platform, internal platform? We did agree, we had some debate, but we said, okay, internal platform is a valuable term, and that's the reason why in that subtitle, no more, no less than your use cases. This is like, it just seems worth mentioning. You need to be meeting the use cases. Like, you're trying to build web apps, then you need to provide web apps. You need to provide the capabilities to build web apps. You're trying to let people run COTS, commercial off-the-shelf applications, third-party applications, then you need to think about that. You want to enable people to do data science and ML ops. Think about that. What does your enterprise need? So no less than what your enterprise needs. And believe me, I've talked to customers who are struggling. Their IT teams struggle to know what their app dev teams need. So that's an important part. Like, this is an internal platform. You got to cater to your internal needs. and also know more. We thought that was worth calling out. Like, there are companies like Spotify or the folks that did Argo that open source, and they try to cater to the industry-wide need, but that should be a non-goal for most of us. Focus on meeting the needs of your enterprise. We tried to delineate, on the why. This is what I was saying before, the business case that you could build up. Reduce the cognitive load is a term that people know from many industries, so it resonates with folks. Basically, your app developers have to know too much these days. So by moving some of that stuff into a cross-cutting platform team, you're making their lives easier. They can be more productive. By moving them, like if a classic DevOps arrangement might have a different DevOps person in 10 different product teams, each doing things slightly differently. You want to improve reliability and resiliency of those capabilities, start to put them into a shared team, start to let them create common patterns across the enterprise. That's also will reduce risk. But then a really important one that's been coming out as I talk to people is when you are owning your platform, even if that just means the top layer of it, it makes it easier to bring in managed services. Folks here, maybe you're all in on AWS, and then maybe this isn't a concern. AWS is your platform, basically. But if you're, kind of bringing together multiple SaaS, software and service providers, cloud providers, if you don't put a layer over each one, it's going to look different, and you're going to surface that complexity up to your dev teams, and they're going to end up with a million different patterns for integrating. So bringing in managed services, if you can bring them into your thinnest viable platform. Sorry, I use that term. And I used to have a graphic here that kind of illustrated that. There is a term from some folks out there, thinnest viable platform, and that can kind of you can keep that in mind. Like, how much can I delegate to a managed service like AWS or to a managed software provider like Red Hat, and not have to create myself? So I just have to own the top layer and a little bit down into it, but not too much further. The last thing I wanted to say, and then I'm going to do some demos about ROSA and all that, is why. Why is this coming out now? Like, why wasn't it 10 years ago that we said you need a platform engineering team, or your DevOps team is burnt out? Some people express it that way. And I think this kind of illustrates it. So this is an app I built this like 5 or 6 years ago, actually. And it's not even that complicated now. I've just got 2 microservices, a web front end, running some JavaScript. But it's all distributed. These are microservices that could be scaled up and down, and that one's another one. But then I need a database, and it's not in a server that my infrastructure team has given to me. It's some API out there. It's Aurora, it's RDS, it's something out. Same thing with Cache and Blum. I want to chunk something off the other queue to some sort of function. I want to make sure everything is observed by some collector and then analyzed in some dashboards. I didn't even get into what the developer side needs, a code editor, fine, maybe that's on their desktop, but where do they store their source, the Git repos? Where do they store their artifacts, their built images and things? So there's all these, we're building distributed apps, and at this point, we kind of need distributed capabilities to go along with that. So I think it's the evolution of cloud native architecture, distributed architecture, which is kind of leading to this need for a team to manage this. What I'd like to do, I didn't get around to it yet, is to kind of draw arrows from each of these. Like, basically, in each of these things can fulfill one of the needs I have up here. Yeah. And so these were, actually, we're trying to kind of suss this out now in my group at Tag App Delivery. We'd love to hear, by the way, if you want to ever come to, we meet every other week, every week, even if you want to come and tell your platform story, we'd love to hear it. These are some of we put in the paper a list, again, we say internal platform, what you need is what comes first. So don't just pick our list, but this could give some guidance on capabilities your developers might need. Okay, so now I kind of set the stage for what a platform is. Now I want to show how ROSA, Kubernetes, OpenShift are a great way to build this kind of a portable, this kind of a platform. And what stands out, and that's why I said portable, is that's probably the main difference between, say, taking AWS all in as a platform, which I'm at AWS conference, if you want to do that, okay. But if you're looking for a portable platform that you can run on-prem, that you can run in other clouds, you know, that you might, yeah, it might not be all AWS. Yeah, so let's talk about what ROSA is. First of all, I hope everyone knows, but not everyone always knows that OpenShift is to Kubernetes kind of how RHEL, Red Hat Enterprise Linux, is to Linux. It's, you know, a downstream, packaging it up, adding functionality, supported for a longer life cycle, making sure CVEs are addressed, you know, all kinds of extra kernel level stuff. That's kind of what it is. So OpenShift is Kubernetes. But it's a lot more than that. But I don't want to miss that it's also Kubernetes. And I even put, like, in my abstract for this talk, like EKS versus ROSA, where you might use it. Like EKS is really about just Kubernetes, whereas ROSA and that's what I'm going to get into, lets you kind of leverage Kubernetes to build a platform. I kind of see EKS as like, okay, that's my container orchestrator within my greater AWS platform. But if you want to use Kubernetes as your platform for platforms, then OpenShift can be a big aid. And I'll show you what I mean, actually. That's the third bullet point here. A really good part about having OpenShift in AWS and how they complement each other really well is the scalability. So do you want to maybe close that door? Yeah, thank you. So like if you want to run OpenShift on bare metal and you install Kafka, let's say, the Kafka operator, and it needs a lot of resources and it needs new nodes, scaling that stuff up quickly is a pain. I mean, it's impossible. What are you going to add? It's going to take forever. You're going to add a new node. The great thing about AWS, and I'm going to show you this, I just click machine set, add me another machine, or I can even auto scale. This happens to me all the time. I run out of space in my cluster, spins up another machine. Of course, I can also, you know, instantly spin up the same cluster in another AWS region. And I won't even mention what I said. You could run, we have equivalent services in Azure and Google too, if you wanted to. The operators part is, operators is kind of what Red Hat uses to describe Kubernetes extensions. It's a way to add more functionality. So like out of the box, if you have people here work with Kubernetes to some degree, who here has worked with Kubernetes? Let's put it that way. Okay, so Kubernetes has some core IaaS concepts, like you want to deploy a container in Kubernetes. It's called a pod. It's a collection of containers, but it's basically, you know, a descriptor to run a container. You want to set up a reverse proxy, a load balancer across several, you know, pods, several containers. You set up a service, and that basically aggregates them all behind one name. You want to set up a way for that service to actually talk to the internet. You set up an ingress, or in OpenShift we call it a route. So that, and you want a volume, you want some disk. It's a persistent volume. You can create one of those. But then you want a database. You want a container registry. You want a pipelines infrastructure. That's the kind of stuff that operators and extensions to Kubernetes can add. I'm going to show you that. And that's actually ROSA is really good at. There's like 300, 400 first party and third party and custom operators that extend that same Kubernetes API, that same platform into higher level stuff. So that's kind of platform capabilities, Red Hat and partners. Actually, I'm going to show you also, there's one called the AWS controllers for Kubernetes, which projects AWS resources like S3 buckets and EC2 instances straight through the OpenShift APIs as well. So it can go that far. I also like to point this out. Like I said before, like OpenShift is to Kubernetes, like RHEL is to Linux. Red Hat is really good at kernel stuff. And so if you need to you know, support a new GPU or support a different driver or pin CPUs to a certain workload, or add a kernel module to every node, stuff like that, we've got some really good tools for that. So yeah, I kind of think, yeah, the advantages of OpenShift are kind of at that low level and then at that platform level. Another one, and this last one, familiar UI, UX, it's the kind of thing like as an engineer, you notice last, I guess, but it's one of the benefits, it's one of the things that people call out to us. You get the same consistent UI. You get a UI because Kubernetes doesn't come with one. In every place you're running OpenShift. So that's nice. And I also am going to show you a backstage-based UI that we're working on. Okay, so, oh my gosh, it's 11:52 already. Well, I'm going to walk through this pretty quickly, so it's okay. I want to show I'm going to make this big. I'm going to show you, so it says in that slide, let's just bring that up, what I want to show you. I'm going to just quickly create a Kubernetes thing so you'll know what it looks like. I want to show you some of the higher level capabilities that operators give you. I'm going to quickly show you what a machine set looks like. I'm not going to actually show the AWS controllers Kubernetes working, but I'll point them out. And then if we have time, the last thing is to actually show a Spring Boot service deployed on this portable platform. So let's go over here. This is what we call the hybrid cloud console. And so it's just console.redhat.com/OpenShift. I get a list of my clusters. I actually have two. ROSA, that's a totally managed cluster, SRE managed. They've got some extra bits into there. This is a self-managed one that I've deployed myself. Sometimes I want to get to the lower level stuff that ROSA doesn't always allow. I can hit ROSA 2. And probably what I would usually do is just open console. This is always the moment of truth where I pray everything is still running. And it is, I think. Come on, baby. That will, yeah, there it turns green. I just want to show you really quick what it would look like to create the simple things in Kubernetes. And because like I said, I think people appreciate this about OpenShift. I'm just going to create HTTP server. What I do is I create a project, which is kind of my tenant space in the cluster. It actually maps to a namespace if you know how Kubernetes works. Underneath that, I'm going to create a deployment. Nice thing about OpenShift is a lot of the stuff has a form field, which is basically just the YAML. It's a special annotation that says, hey, put this in a field like this. I name it there, and then that makes sure that it's all named properly back here. Just going to say HTTPD. So now this is my compute. I need to load balance those things. So I do that by putting it behind a service. This one does not have a form. So I just have to do it manually, but that's okay. Basically, this says which a service is a reverse proxy against those pods. And it says, look for all pods with this selector. And oops, that's not right. And send traffic. It comes into this at port 80. So I'll see that. And then finally, I just need to create a route to the internet. Again, I'll just call it HTTPD. This is kind of cool. So I choose that service that I made. I say I want to hit that port. And I can instantly, this is a nice thing in OpenShift. I can just right away say, okay, add TLS termination, redirect, I hit create, the route's coming up, hopefully it's up, and there we go, and the service is up and running. So it's a nice way to get started with Kubernetes. I can get rid of that now by just deleting the project, but I won't bother. Now I wanted to show the advanced capabilities with operators. So there's two places that are most relevant in this console. One is API Explorer. So remember, I described a platform should give a consistent interface for all kinds of things. Here's where you can find your stuff. So I've actually installed, for example, the Mongo operator so that I can get a Mongo database on demand. I've installed, it's called, the name of the resource is cluster, unfortunately, but it's kind of confusing. But here's my Postgres cluster. So I can install a Postgres cluster on demand. I always have to do that. I've got other things like a Quay registry. That's a fun one. Oops. Quay registry. And I can just declare a Quay registry. I actually have a Quay registry running in this cluster, I think. I can create a Jaeger. That's a telemetry trace system, et cetera, et cetera. So I can do that API Explorer. Not saying this is necessarily the end interface you want to give to your app devs, but it's getting there. And this can be the point of compatibility. Operator Hub is where those things are actually coming from. So operators are that was the API. Operators are the actual implementations. So like when I declare a MongoDB thing, then it's actually going to find, the MongoDB operator in here. I think I'm using the community one. And that's going to do the work of creating it. I'm going to just show quickly here. So I mentioned, here's the Red Hat ones. There are tons of first-party services like pipelines and GitOps and things like that, which I've already installed. Then certified is a lot of our partners, so things like Redis, AppDynamics. And then there's also Community And marketplace are ways, that's a way you can pay for it through IBM. So some of them are paid. That's marketplace. What was the next thing? Yeah, so that's a higher level capabilities. And I want to show, hopefully we'll get to it, the Spring API server actually uses, it's just a bunch of files and it describes the different custom resources I'm going to use. The next thing I wanted to show, I mentioned that machine sets, which I think is super cool. So machine sets here, I actually, in this, I have to control it back through this console. You see it says machine pools. So let's say by default right now, I've got a machine pool. It's saying I got 2 to 10. I was able to do this all in the console. So it scales up when I run out of nodes. Here I have another one that's I'm able to manually scale even. And I can just hit 4. And momentarily, you'll see the machine set in my cluster. Yeah, you see it says 3 of 4 machines down there. So now one of them is coming up, which is really nice for me at least. So I can quickly get the resources I need. I did want to show the ACK, the AWS controllers for Kubernetes, since this is AWS, and this is, a lot of my customers ask about this. It's a whole set of controllers that let you have Kubernetes descriptors, Kubernetes manifests for AWS things. So like, yeah, I have ACM, I'm not that familiar with, but there's DynamoDB, EC2, S3, everything you want in there. You can even set it up to work with IAM roles so that you have an account that automatically can create things in the right way. Okay, before we wrap, I do want to show you the end result of all this. So like the end result of all this is to serve our app developers, right? So if we go to GitHub, Josh Gav, here is a Spring API server, which is ready to be deployed on any of my clusters. And I'll just show you the core of it really is this base, folder. And this is not a very complicated app. I just didn't have time to make it that complicated. But there's a deployment where I deploy a pod with my built Spring service in there. Here's an instrumentation, which allows me to instrument it automatically with OpenTelemetry. I've added all these capabilities to my cluster already. That's kind of what, so till this point, I was talking about how you build a cluster or how you build a platform with all the capabilities. Now I've switched over to the app dev persona who's using my cluster. And this is what the experience, at least the basics, like I said, you could build further on this, but this is a base experience for them. Here's my PGDB, that's the Postgres cluster, pretty simple. Here's the route, that's the ingress, service monitor, which is a Prometheus thing. And then all of that, I've got a pipeline defined here. This is on PR and on pushes. And then at the end of the day, once that pipeline runs, I get, let's do it from OpenShift on AWS. I get my pods running here in Spring API server. And I will have a route for them here, and I can click and go check it out. That one just says hello world, but I actually have it working with the database, returning widgets. So there it is running. The last bit to show is that the last element I would say in a platform is helping your app devs get a view on what's happening with what they've deployed into the platform. That's what we're beginning to call portals. Who here is sort of Backstage? Anyone heard of Backstage? That's a popular project in CNCF right now, from Spotify originally. And that's what this is. Red Hat's building something around this called Developer Hub. And this is a single place where developers can come in and see things related to their application. This is not so complete, but at least you can see my GitOps process, my pipeline run. Here's the last bunch of pipeline runs. Here's my registry. Here's even a little bit, not the best filtering right now, but it's got the actual pods that are running. You can pull in docs. Another big thing about Backstage people like is you can also create templates that will create new projects for yourself, like create a Spring Boot backend with a CI pipeline. So that's kind of the, let me go back to the deck now, we're about done. That was deploy a Spring Boot service using the platform. And then Yeah, and so, yeah, that's it. I wanted to put up the product page. You can go try out Rosa within the AWS console or the Red Hat console. I actually wrote a post like a year ago with not just Rosa, but 2 or 3 other ways to deploy Kubernetes and OpenShift and AWS. So check that out. Yeah, and I'm around. And if you want to talk Kubernetes, CNCF, Red Hat, come find me.
Good lunch today. Nice Chicago style lunch today. I'm going to send it over to Stephen.
Cool. Thank you. Thanks for coming. Thanks for sitting in the room. I don't like public speaking, so I'm a little bit nervous. But today we're going to look at intelligent automation for AWS infrastructure using Terraform and Structure.io. I'm a developer for Villatech. So I've been at Villatech for the last 8 years. We primarily work on networking, cloud networking, professional services, and managed services. And what we found was that we have a very wide range of skill gaps from your experienced engineers that are used to building stuff in the cloud, and then we have our interns coming in that have absolutely no clue on how to do stuff with infrastructure as code, and we're trying to ramp them up as fast as possible. So what we aim to do is build a platform where we can kind of compress that skill gap, make things very simplified, easy, and quick to do. And we did that with a tool that we have been developing in-house called Structure.io. So most of my demo today is actually going to be a live demo because I live life on the edge. So this is Structure.io. It is an abstraction on top of Terraform. So everything that we do within Structure.io is built in Terraform code behind the scenes. So you can take that away. So in Structure, we have our workspace in the middle, and we have our provider panel. Within our provider panel, we can then filter through all of the AWS resources. As this is Terraform, we do also support many other providers. There's 300 out of the box, but we can filter through these resources really quickly. We can search through them. We can find, let's say, a VPC, and we can drag it into our workspace. Once we select the VPC, we're presented with a few different things. We've got our config panel here on the left. We've got quick chips, and we've got our HCL view. So the whole idea of Structure was to teach everyone as they're using Structure, let's teach them Terraform. Terraform is a great tool. As you know, vendor agnostic. It works everywhere. It works for many different platforms, as like cloud as well as appliance level stuff. So to teach and to assist with the Terraform code building, we can really ramp up the skill gap. Teach the juniors really fast and get things going really quickly. So once we have the resource selected, we can start configuring the resources. So
this resource you're doing is the VPC one?
Yep.
Okay.
So building a VPC, added a side block. We can add tags. If I could type. There you go. AWS Community demo. Or AWS demo. That'll do. So we can quickly add the resources. Let's quickly name that as well, demo. And that was from drag and drop. Very simple. But we want to take this one step further. This is where Structure began, drag and drop. That's not that fun anymore. AI is the new big thing. So we wanted to build AI into this. So we've done some cool stuff with it. We can add a resource into our AI. So what this is going to do is give context to what we want to ask the AI about. So we've selected our VPC. I can say create a subnet. So I've given it a reference to the VPC. If everything goes well, demo gods, be nice to me. It's found the VPC that I passed into it, is given it a side block. It used the next subnet that we have in that range, and I can add that to the workspace. And you'll see that it's also linked my VPC to my subnet. So this is another area of Structure that came really handy for people coming into Terraform, used to doing things in the console. The links really show the relationships between things, and it helps identify maybe mistakes when you're writing code by hand. Maybe I referenced the wrong VPC. So the links kind of validate exactly what you're doing. Does everything look like I'm doing the right thing? So we can also refactor code with the AI. So if I select the VPC again, being crazy, there we go, select the VPC, right click it, start a new chat, we can start refactoring. So use a variable instead of for the slider block. So I was going to understand the code I've given it. It's going to default my variable name. Again, it's going to update my current VPC, and we're going to update that in place, and we're going to add the new variable to our workspace. Again, showing relationships between, the variable and now the VPC. We've updated that VPC as well, as we can see in the HCL there on the right. So we can utilize the AI. We have an example online, is quite fun, where we convert something from Azure into AWS, selecting a whole project, highlighting the whole thing, asking the AI, how do I do this in AWS? And it will convert everything to the better platform. So the next part of it is, not everyone knows how to write good code. So if I open up a project where we've built out a few things, so here we've got our network, we've got compute, we've got outputs, variables, and security groups down here. I've purposely left some stuff that's not right. So as we're building the code, we have an analysis tool that's constantly scanning our code in real time. Am I doing the best practices for AWS? Am I tagging things properly? Am I adding descriptions here for my security group? Am I enabling the HTTP endpoints on the instance, for example? So we get that feedback in real time as we're building things. Again, people who aren't familiar to Terraform might not know that that's what they need to do. So we make it nice and available to them. We can add the description. Demo, it's going to scan my project. Now I only have 2 mistakes within my project, which is a lot better than what I was before. Also validation. So say if you're copying and pasting code from online, which is what we all do, right? And we have an old example that, didn't have the right syntax for something. We used a string where it should have been a ball in the tool, again, exposing things. So we're scanning the code in real time again, and we're telling the user, that's not what I wanted to do, or Terraform saying, that's not what I wanted a ball. Let's change it to that, and let's fix it. Now we have no problems in the project. As well as presenting the code, we also have documentation. I think one of my biggest pain points with working with something like Terraform, you're always back and forth between an IDE to the documentation, trying to find the resource you're working with, trying to find exactly what those parameters are, or what they do, what they mean, and how do I fill them in. Some of them have options that aren't necessarily obvious. So we have that built straight into Structura. You can reference those things. Again, saving you time, just making things a little bit easier. I like the easy life. I'm gonna switch project again to an EKS build. Within EKS, similar as before, this one has a better demo for showing cost. So as we're building stuff in AWS, I think I've definitely caught myself out a few times. We've scaled something up too far. It's cost me a lot of money. I want to cry a little bit, and then I have to pay for it. And I think something like Terraform, that's very easy to do. You're not necessarily aware of what the costs are associated to the code that you're writing. So we have the Cost Explorer built straight into Structura too. So with the Cost Explorer, we get an overview of exactly how much this deployment is going to cost us over a period of a month. But we can also play around with this data too. So let's say if I want to scale up my workers to 4 workers, we can increase the price. If we want to go back down to 2 workers and we want to say they're only going to be active for half the time in a month, we can scale that down. So we can predict and calculate exactly how much our projects are going to cost. And we're developers or engineers, cloud engineers. Sometimes we don't really care about the cost, but there are people that we work for that do. So building this into your code, reporting on it, and this can all be integrated with CI/CD platforms. You can open up that visibility into your projects, communicate with the financial people that do care about it, and gain awareness across the team. So yeah, it's been really handy for us, and you can quickly spin up projects. You can change things around. So if you want to switch out for a different architecture style, how much is that going to cost me versus how much my current architecture is going to cost me? And you can kind of calculate that before you're actually deploying and incurring those running costs. The next thing that we wanted to add to Structura is importing. So I think a lot of times we sometimes go to the console, we add stuff, but our company want us to use infrastructure as code, which is all great. I think there's many, many benefits to infrastructure as code. Sometimes it's easier just to mock something up right in the platform itself using the console. So we built an importer. So the importer is going to scan all of our existing resources within AWS based on some filters. So I've tagged some stuff that we have running. I can't talk and type at the same time, bear with me. So tag some stuff in AWS. We can then select those services that we actually want to import. So let's say EC2, security groups, VPC, and a subnet. And this is now going to scan my live infrastructure. As long as I typed everything in correctly, we should get some results, which we do.
So this is a good example because me being on the engineering side, you being on the developer side, we're in the console building out the infrastructure. We don't know the infrastructure as code, the Terraform code, how to build that out. So we build this entire environment in AWS, and they're like, well, we got to get into a code. So this is a perfect example of how to take what we built in AWS, now import it into a project where we can manage it as infrastructure.
Yep. So from the tool, we can import everything. We can click the import button. So what the import button is going to do is convert everything that is found in AWS, change it to HCL, which is Terraform's language. It's going to run your Terraform imports behind the scenes. So once Terraform is handling something and managing something, it needs to know what that resource is in the state file, so it can calculate drift or changes between that infrastructure. So now that's imported, I can sort those nodes. We can make it look pretty if we need to. So just drag these around a little bit. And now we have a representation of what we have already in our console. Everything has been converted to HCL. Let's open up that again. So we can see the HCL block that has been imported directly from Terraform. If you were doing this by hand, it's kind of time consuming. Yeah. I've worked on projects where I've had to import about 460 resources. If I had to do that by hand, I don't know what I would have done with my life. It would have been a bad time. But with the import tool, I was able to do all of those 460 resources in a couple hours. And you know, it gets you most of the way here. You might want to change things. So there might be standards that you have within your organization or code practices, code styling, so on. You might want to templatize some of the things, change things out for variables. But again, we can use that AI. We can select those resources. We can say, switch this out for a variable, or modify it in a certain way. For example, I think security groups probably is a good example of where you might want to use the AI, refactor the ingress and egress rules into separate resources. That's the recommended way of doing it within Terraform. And you can utilize the AI to quickly refactor. And there are some little caveats. I'll highlight some now. So the AWS API wants the customer owned IP on launch to be defined, where Terraform does not. So if I was to run a plan right now, which I can do straight from Structura, is going to complain about that. So there is a little bit of cleanup that we have to do. So just remove them from the subnet. And you can do that both from the config panel and from the HCL view. And I messed something up. I'll just get rid of that. And now it's comparing what we have online in AWS versus what I have in my infrastructure as code. You can see no changes. So we have a 1-for-1 match within our code very quickly and very minimal effort compared to doing that by hand. And yeah, we're pretty much there. Did you want to talk some of your experience?
Well, I mean, some of the things that you were just mentioning, you want to go to the console, make sure a change in there. Let's say we got this example of a project that's for stage or some sandbox environment. We want to change this to a production environment. So change some variables, change some IP addresses, and you can see how that looks from this perspective. But if we go to the AWS console, it'll do that update for us.
Yeah, and you also reminded me one of my points that I didn't mention too. So when we run the plan, Structure is taking the output from Terraform that we'd normally get. Those that have worked with Terraform, you get created, updates, deletes, and it will tell you exactly what's changing. You can see that here. So at the moment, I've got a variable here that's or a ball that's changing from false to true. With Terraform, say if you have a very big build, sometimes it's very easy to miss something. Within Structure, we also highlight exactly what's changing within that deployment, again, in real time. So we can see here that the public subnet has a change, the instance has a size change there, and the security group has the description that I added. If we were going to do a bit more of a destructive build, so let's say we change the whole network spacing, and this is where you can get caught out sometimes if you miss something. So we're running the plan again, it's scanning changes. And then if we run the plan view now, we can see everything with a red dot is actually going to get destroyed and replaced, which obviously, if you're in production, that's a bad time. Again, we might not want to do that. Sometimes it's expected, but the plan view really helps, stop that from happening before you push a change, as well as integrating with your GitOps workflows, having approvals and so on. You don't have to push directly from Structure. You can do whatever works best for you and your organization. Yeah, as Kamal saying, let's make a change. Let's go back to the import project. I didn't save the position, so let me.
Yeah, maybe we go to the AWS console and see what it is before, make
Yep.
a change. To that.
Yeah, bear with me. Console. This is East 2.
Right. So the whole idea, infrastructure as code is to make it coded, right? So if you have a change, and we're talking small changes, but I'm developing projects with my team. We're talking transit gateway load balancer, third-party firewalls, virtual appliances, spoke VPCs. Then we got to add another VPC. Having to do that manually every single time takes a lot of time. You treat it as infrastructure as code. You can do it for your dev environment, your stage environment, your prod environment, and then also create that template. So not only for this business side of things, but for a different business. Just change your variables, change your naming nomenclatures, change some variables, and now you have that exact same template that you've developed and tested and know it's true and good, put it to a different business side of things.
Yeah, thanks for that. So while I was talking there, I was just changing something simple, a tag. So we've changed the tag. We can see that in the plan. We're changing it to welcome AWS Community.
The tag is for which one? VPC?
This is for the VPC.
So can you show the tag or?
Yep.
Yeah, let's
So
see what
we
that
currently
looks like.
have Structure import demo,
And then just changes it right there
updated
for
in
you.
real time, console
There you go.
updated, and we push those code changes. The other thing to note as well with the import, because we are scanning it as we do the import, so you can import customer environments, find anything that needs to be tweaked, improved, and so on within their environment. You can work through those tasks within Structure. It's a nice list, so you can just go through them, fix things, improve things as you see fit, and you're not wasting time trying to dig through all that HCL code. Everything's highlighted straight away. And yeah, that was.
So another thing you want to highlight is the validation point here. So again, being from the engineering team, I'm learning it. I'm still trying to get Terraform under my breath around, but I'm coming from an engineering side of things. He's in the developing world all day, every day, so he's on that side. He doesn't know engineering. So we kind of match and clash and like, how do we do this? How do we build and stuff like that? So this helps us. If he's busy, I'm busy. It helps us kind of validate our own work and say, okay, does this look good or am I missing something? I don't have to reach out to him when he's on a meeting or on a call with the customer. I can actually go to the validation tool and see, oh yeah, I'm actually missing this syntax, this is wrong, or this is coded not the right way. I don't have to reach out to him every single time and be like, what am I doing wrong here? it'll validate that for me. The analysis tool is huge because I have team members that are brand new to AWS. They've never done it before. What am I doing wrong? Is the best practice? Am I missing something? They can go through a validation of the analysis and say, oh yeah, he did mention that when we were talking about it, or I did learn this, that I did security with that. Everything has to come down to more fine, zero trust perspective, at least privilege. So that helps our team out of the analysis and the validation side of things. Maybe we can try to do a demo of like add a VPC, add some subnets, create a route table in that OpenAI portion of things. So let's add a little bit more complexity to it. Just to show, like we have what, 2 subnets here?
Add 2 more. There we go.
And then you want to add those 2 subnets to a route table, create a default route to something.
Yep. So it's going to take everything I've fed it. It knows what subnets are already existing within that environment. It's going to fix those cider blocks for me. That was going to take a little while for the demo to go through this. But yeah, it's referencing everything I've given it. So it's going to use everything that matches the other subnets that I highlighted and then change some of those parameters. So it's going to keep things very similar to what we had before. We're going through the second subnet right now.
But you can see the key piece here is that you can sit back and watch this do it for you. You don't have to learn Terraform overnight. You can have a tool help build those resources for you. There's things that I don't recall. What are the required parameters for an HCL code block for Terraform resource? This builds it for me. It'll validate it, and if I'm missing a parameter and I change it and I do something wrong, it'll catch it.
Yep, so we can run a plan again after adding those 2 subnets. If everything went well, we'll see 2 resources to create, which we do. And before I push it, subnet says 3 currently, we're adding 2 more into here. Push those changes, confirm it. Again, don't have to do this through Structura. Structura is actually writing all of our infrastructure as code to your file system as Terraform files. You can integrate that with Git, like as I mentioned before. Looks like that pushed already. Give it a refresh, and now we have our subnet. So very quick. I didn't have to type anything, didn't have to do anything apart from add 2 more. That's what I added to Structura, and it's created those 2 subnets for me. So yeah, open up to questions. We'll also be outside the room if there's any more questions as well. We'll hang around. So yeah, feel free to. Yeah, I've never had it respond with, I don't know how to do that. You are right on the hallucination side of things. And I think that's our saving grace as engineers. You still have to have expertise into what you're trying to do. For the most part, is going to get things right. The biggest downside I see to something like OpenAI is that it might suggest something that's from, a slightly older version of a provider. So something might be deprecated already, or it's not giving you best practices. So security groups are a good example of that too. A lot of the times, and route tables, a lot of the times it will try and push those routes into a route table. So you have a route table and then nested routes inside of that. But you can fix it through the AI too. So if it suggests that, you can say actually change those routes to use the AWS route resource, and it'll pull them out and add them as separate resources. So yeah, AI is definitely not going to replace us at this point. I hope. But yeah, I think you still have to have that fundamental knowledge of what should be there. I see it as kind of a pair programmer, someone that's looking over my shoulder. I can ask it a question, and it's going to help me, get most of the way there. I just might have to clean up a few things. Yep. Yeah, we support modules. So we support that's not structure. This one, we support all of the different blocks within Terraform. So modules. All my examples today have been using a root module essentially, but you can import a module, select the source. So the source can be from your local file system. It can be from Git, it can be from the private registry, or Terraform's public registry. You just select the source, initialize, and it will pull it in, and it will read the schema from the module based on the variables and the outputs. Yes.
So, related to that, is the AI system smart enough to know for my office? So I say, give me license plates.
It's not smart enough now, but that's a great idea. I think we'll do that. Yeah, it doesn't know what modules you have
So it's gonna write raw Terraform.
most of the time. Yeah, you can say like modulize, select something, modulize it, and it will, make variables and outputs out of that. But you'll still have to build it with that in mind in your head, make that module to start with, and then ask the AI to input those resources into them.
It goes in their server, the activity server. So in this case, does it send any data back to their server?
Not muted.
Sorry, feedback over. So ChatGPT stores its data for 3 days. It's for basically policing. It doesn't share. So if you were to post something to ChatGPT, it doesn't use what you sent it as a response for someone else. They keep it there just to make sure people are behaving as they're using it. And that's all in their policies, their terms and conditions of ChatGPT. No, so it's not storing it on their side other than for the audit trail. It's not data that ChatGPT then references in the future. Yeah. You'd have to do that within the conversation. It's another great idea where we could store those previous conversations, but at the moment it would be a sequence of messages back and forth between a user for one specific conversation. As soon as you clear it at the moment, it will be from scratch essentially. But it's a great idea.
Right, so if you had a resource that you created from the chat, just like VPC, just create a subnet, for example, and then you decide, I don't like this CIDR block, let me change this up. So if you try to do that right now, you can see very different from just create a subnet with CIDR block 10.10.00/24. It'll create it, and then you decide, oh no, I can't use that, I'm using that for something else. Make it 10.100, or you can't think that you forgot the 0.
Yeah, so the other thing you can do as well to add to that is you can close the chat and add a new block to the history, to the conversation. But like I said, as soon as you clear it, then you're starting from scratch. So you can continue an old chat, the previous chat essentially. But anything past that, it will be from scratch. No problem. Yes. You could probably talk. I haven't tried to do that personally. So when we have multiple environments, we use workspaces for the most part. So we switch workspaces within Terraform, which is down here at the moment. I only have a default one. We could add new ones. Mhm. Serverless as in just Lambda or serverless? Yeah. I haven't tried it. I would have to come back to you on that. I'll get your contact information maybe. Yes. I had a hard time hearing you then, sorry. You say Terra Grunt? That's something that's in the roadmap for now. So it's one of the next tasks that we are adding to Structure to support Terra Grunt and the way that they structure things. So yeah, coming soon.
And I am taking my drink with me.
I was wondering about that. That line. Yeah. So I want to share the entire desktop with that.
Okay, you're gonna be switching back and forth.
Yeah, it's like plus.
Sure.
Recording in progress.
We're gonna allow this
Sure.
just so you're able to screen share it. So you can.
Yeah, no, it's fine.
Just gotta reopen it.
Okay.
Share screen. I'm gonna hide this so you don't see that.
Okay. All right, good afternoon, everybody. I'm Girish Bhatia, and our topic for this session is AWS S3 static website hosting and CI/CD pipeline using GitHub. Sort of, I combine two different interesting concepts into one topic. So we'll show you like creation of the static website, which I have already created, but there are screenshots from the workshop perspective that if you want to create your own static website, you can follow the steps and get the site created. And the second segment of this, which is CI/CD pipeline, I want to show you the CI/CD pipeline in action. When you update the, your web page, the pipeline gets hit and it fetches the content from the GitHub and updates the site without any manual intervention. About me, just some idea experience, journey, like everybody else. So software engineering, different technology, moved into the technology and then the cloud. That same technology interest, keeping up with the cloud technology, passionate about AWS technology, and every day is a new learning as AWS keeps coming up with some new services and add on to the existing services. So in this, we'll create the static website, we'll run a CI/CD pipeline, and then we'll see that how the website get updated without the intervention. S3, that's a popular one of the oldest surveys that AWS came up with. Simple storage service, any object you store, any kind of file, PDF, image, MP3, anything that you can think of. So it's an object storage. 99.99% availability, 11.9 durability. So very reliable service. Anytime I'm looking at AWS service, I do recommend that you set up your budget, if you're playing with it, get yourself familiarized with the cost explorer. so that if you are not using the service, you know what your budget and cost gonna look like. Some of the steps to create this static website and then enabling it will upload some simple files, organize the HTML, CSS image, and other content file, and identify index. This is what we will see it in action. So start with the console, AWS console. Select S3 as the service, and you want to create a bucket. Give a name to that bucket. In this example, I have Chicago AWS meetup as the bucket. Select the region, and pretty much you select the default setting to get the bucket created. By default, your bucket will block all public access. That's for the security reasons. But in this case, since we want to create a static website, we can block it. So uncheck the block all public access settings, and that will create your bucket. Once you have the bucket, the static website is a special setting here, which is by default disabled. So you edit it, enable the setting. When you're creating a website, you have to identify a home page and another page. So this is the index.html and error.html. And that will give you a endpoint for the website. If you try to access the website, you will still get a 403 error, and that's because one step that is required for the static website is the bucket policy. And this is an example of the bucket policy that allow all the gets to the URL. Once this is done and you hit the URL, that site is set up. This is as simple. So traditionally, getting a web server, getting a physical like web servers, and then doing all the deployment is all pretty much done by getting your file into the S3 bucket and changing few parameters, organizing your files, and you have a very simple static website running in AWS. So this is just the live example, right? This is the URL, the site, the bucket that I have created, and we will make change to it and see how it gets refreshed. But this is an example of the static website, very simple page that I wanted to show you. Once you get the endpoint, what's next? Because it's still not a very friendly URL. It's a point of endpoint to the bucket. So couple of things that can be done next. By a domain, AWS has another service, Route 53, or you can buy it from GoDaddy or any other domain provider. Update the CNAME tree and the public hosted zones, and you get a DNS of your choice that you have purchased. By default, it's a HTTP protocol. Of course, you can make it HTTPS by buying a certificate. And for that, AWS has ACM as another service that allow you to upload the certificate, create the certificate, and use the HTTPS protocol for your site. Services so far, AWS Budget, Cost Explorer, S3. Those are the ones that I have used. Route 53 ACM CloudFront potentially can be used for a production website. Multiple ways to upload the contents. The simple way, use the AWS console and load the content. You can use an ID of your choice. I use the VS Code. And if you are into CLI, infrastructure as code, then you can use CLI to upload your files into the bucket. So another simple example, like any other front end, AWS provides you an upload function. You can upload the files there. So this is the simple approach. If you are into an IDE, especially VS Code, very popular, there is AWS Toolkit extension that you can add to your VS Code IDE. And then that AWS Toolkit actually will provide you access to many different AWS services. S3 is one of them. Doesn't provide you access to everything, but it has all the popular services. So you can directly access your bucket. You can directly update your files using this extension. And then, of course, you can use the CLI. This one command I really like because, after I have all my files into the S3 bucket, I can just have a backup of that in my local by running this command, because it will fetch everything from my S3 bucket and give me a backup for that. So CI/CD pipeline, many different services that AWS provide: code commit, code build, code deploy, and pipeline that puts it all together to create the pipeline. So in our example, we are not using the code commit. Reason being that I'm using a GitHub, which is another popular code repository. So code commit is basically AWS service. If somebody doesn't already have GitHub or wants to use code commit, not using the code build because it's a static website, so there is no code to be built, but we do have files that we need to deploy. So that's why deploy, pipeline, and AWS S3 service. Going back to the basic, right? Like when we're talking about static websites, I mean, traditionally, years back when we started, there was just one server, somebody loading the file, and there is a static website for either for personal portfolio or small business, on-prem, more mature organization, multi-steps, physical infrastructure, the dev, the test, the product, all different kind of setups, expensive setup. With AWS cloud, it's all cloud, right? You don't have physical infrastructure here. In this example, you have the static website, you have the CI/CD pipeline, and everything is managed for you, pretty automated. So next, I would like to show you the code pipeline, and then how it updates the S3 bucket. So again, pipeline is another AWS service. So from the AWS console, you go find the AWS code pipeline, click on create pipeline, give your pipeline a name. You allow if you already have a role, then you use the role. If you don't have it, allow code pipeline to create a role so that it can use it. It provides multiple options. It's very friendly. So in this example, I'm taking GitHub as the source for my source stage. It could be code commit. Once you have the GitHub selected, it provides you connect to GitHub if you are connecting it first time. If you have already connected it, it will remember your connection and you will find a connection. It will show you your repository in GitHub. It will show you your branch, and you can select all of that. You then select your deploy provider. You select the region. In my case, I have selected US East 2, which is Ohio region. The bucket name, my object key, and it before finalizing the pipeline, you will see a summary of it, and then you have a pipeline. So I have an active pipeline that I have created following these steps. So let's look at that pipeline in action. This is my current page that I have in S3 bucket. I have VS Code with AWS extension setup, and this is my index file. If I make a change here and say, add something here, let's learn together, and I save it. If you are familiar with VS Code, you will see that it's telling me that I have one change that I need to commit. So I will commit this change. This change is getting saved in my source repo, which is GitHub in this case. I do want to watch my pipeline here. So this is my pipeline. And let's see if it gets triggered. Simply change it. Simulator. This is my pipeline, and if you notice, it just got triggered, and it just said, and if you let's see what you will see the progress on the corner, will show you which stage it's following, and in my case, it's a source, it's a deploy, and I have added an action which is a manual approval because I want to control that. Even though it's all automatic, if I have a real working site, I do want to have some control mechanism. So this is the manual approval part. It's waiting for the approval. So at this point, if I refresh my web page, I still have my original web page. Change is not yet implemented. But if I go back to my pipeline and I say, okay, review, and I do approve this change, you will see that it's kicking up the next step in the pipeline. And once you see the check mark that it has deployed it, you will see deployed to prod just now. If I go back to my page here and refresh it, should have the refresh message. So very simple example, but the power of like AWS services without like having any on-prem server setup. There's a static website hosted in S3 bucket, the service with almost most durability. And you have a build process, you have a notification process, approval process built into, and a fully automatic deployment using the AWS pipeline. If let's go back And again, this is the screenshot of the same real service that I was showing you. And if I look at my S3 bucket, it will show me the latest file in my bucket. So let's look at that also. So let's go to, let me refresh my S3 bucket here. And if I see my objects, you will see that all of these objects got updated just when you were doing this workshop. And again, if I go to my GitHub, then same thing. You will see the message that I put through the VS Code, where I said my commit is updated to message. 4 minutes back, it got updated here, it got updated in S3, triggered the pipeline. So everything is working together. AWS services, AWS budget, cost explorer, S3, around 53, code pipeline, VS Code, GitHub. Many different tech stacks coming together and working as a cohesive piece here. Now, this was a very simple example. Of course, in real life, you're not going to have that simple example, but again, I have this site, just an example, right? This is a full site. I have posted it using the same pattern that we just went through. It's a S3 static bucket. Of course, has a lot more objects into it, all the images, all the CSS files, HTML pages, but that's the power of technology that AWS service brings. That very simple setup, no web server that I need to worry about upgrading or hosting. I have a site with all the contents, all the structural contents I need, and is powered by AWS, and it has all the pipeline built into it. So these are all the services that we have used, and slides will be available in the GitHub. My information, if there is any question. Typically, the session takes much longer because everything it's a workshop, doing it like online. But knowing the technology and being in technology for so long, I also know that sometimes things doesn't go as planned. So that's why I had this screenshot. So if you don't have any question, then I want to make sure that you see how it also gives, if you want to repeat the steps, then you have the visuals of those parameters that I have used to create these slides. Any question? We do have a few minutes for questions. Sure. S3 is actually, I think, one of the most cost-effective service. Lot of like, I have a lot of friends who work in and some big banks, and I don't have any discussion with them that is it's very interesting, like all the, like, we don't do a check nowadays, but like, you know, I was actually curious as of this morning, just exploring that, what does it do? Because I'm using this service, I'm not using it professionally, right? I have my site hosted. So I'm curious that how much, it's gonna like bill me. So far, it has not billed me anything because it's a free tier, right? But I was curious. So I did AWS provide this really neat pricing calculator that I was looking at it. And again, I don't know like how accurate, right? Because it does ask for like multiple parameters, but I put some very simple parameters into it. And like I put like 10 GB data. I will say, so this is what it's like. So I'm not gonna be anywhere near to 10 gig data transfer, but just it's very cost effective. Just like many other services are out there, right? Now we have seen since morning in multiple sessions that like FinOps and cost, right? That's a very evolving topic. So that's why when I started my presentation here, the first thing, of course, is that yes, it's very cost effective, but again, it's a shared responsibility model. So monitoring the cost or knowing the budget is a customer responsibility, right? But the tools are all out there to watch what the cost gonna be. You have a question?
So my question.
That's a very good question. So now I have not done it in this scenario because this is a static website, right? So now the pipeline can be very extensive. So if I put your question in context, in this particular case, I can evolve the pipeline by adding the actions and driving that where to put the content, because I control that which bucket it's going. So like, an example that I was showing where I said, I built an action that deployed to prod, right? I can have an action which said deploy to dev. And once that looks all good, then I can trigger the next one, which basically deploy to prod, right? But that's a static website. But if I take your question in a broader context of pipeline where you are actually building the code and compiling it and then deploying it, it's a more complicated, like outside of this topic kind of a structure, then there are services which provide their own staging way to have the dev and test and prod deployment, right? Like if you say like API gateway, like it has its own stage that you can say that this dev, this is like test and this is prod and control through the pipeline. But yes, it's all different actions, all kind of actions that you can define and control the behavior. Yes. Amplify, I have not used it, to be honest. So I don't have like much comment on that. I know that okay. Got it. Got it. Yeah, I have not used Amplify, so I don't know how like especially with the S3 bucket, right? How that will like fit and all. This scenario is very, like, I find it very interesting because typically the pipeline is like easier in terms of building the code and API and Java and pipeline. But okay, to combine it to get like this, that was like something that I found interesting. Any other question? All right, if there's no other question, thank you so much for your time. All right, good afternoon, everybody. Hopefully you're here and excited to learn about automating storage migrations. I am Dave Stavaker, Chief Platform Engineer at Direct Supply. We're based up in Milwaukee, and we are a company that focuses on products and services for the long-term care industry. So think like assisted living facilities, nursing homes, things like that. I've been with the company just shy of 22 years. And for about the last 20 years or so, I have specialized in data storage and data protection. So between 2003 and 2019, when we made our big cutover into the cloud, our storage platform grew by 30,000%. So I was certainly given a lot of opportunities to learn and trial by fire to learn how to manage storage. So 2016, we were facing a looming crisis on the horizon, needing to renew a lease in a colo facility, lifecycle our entire SAN and NAS infrastructures, as well as overhaul a number of other systems in our data center. They all kind of converged at the same time. And that made the economics of cloud very attractive to our financial people. So in mid-2016, a small group of us started experimenting in cloud. And in 2017, we formed our first cloud engineering team and started rolling forward with migrating in the cloud. Now, fun fact, this is my third time presenting at Midwest Community Day, actually fourth time now because I was just pulled into something. But this will be my fourth time presenting at this conference. And I mentioned I'm an AWS hero nominated by the storage teams. And all of that happened because of my first talk at this conference. So if AWS hero is something you're interested in learning more about or getting more involved with the AWS community, feel free to come see me afterwards. I love talking about this stuff and how this platform here, this conference can be a real springboard for your career. All right, so background. Today we're going to talk about our corporate monolith file server. This thing has been around longer than I have. It is old enough to vote. It is old enough to drink, and it's probably old enough to rent a car without paying extra penalties. It is massive. And so in 2019, we had to get it out of our data center and into the cloud. So the picture you see here is actually my teammate, Jack, with our entire file system on an AWS Snowball, pedaling it with one of our delivery carts, getting it over to send all of our data back to Amazon to start seeding it in the cloud. I've been working with Amazon on the FSX platform, both as a beta tester and on their advisory board since early 2018. And so we knew where the platform was going, and we knew it wasn't going to be ready when we needed it in 2019. So we picked a different cloud platform. It was a third-party thing that we could run in AWS to be our file system of choice for the first few years. And then when FSX was ready for prime time, we started the project to migrate over to it. So this file system, when we moved it out in 2019 on the Snowball there, it was 9.5 terabytes, maybe 10 terabytes. It's now 20. And so we had to move more than double the data we did in our first shot out to the cloud. Also, fun part of the migration is that there's a small subset of the data that's made up of over 1 billion 1 kilobyte or smaller text files spread across 350 million directories. And so moving that proved to be its own set of challenges as part of this migration. And we'll talk a little more about that in a minute. All right, so we went into this very optimistic, and our plan was we'd deploy FSX. We would use AWS Data Sync to synchronize the data from our old file system onto FSX. Once all the data was copied, we would take a maintenance window, failover
everything would be great. We thought it'd take a few weeks, maybe a month to get this done. And then we'd have a big party to celebrate. It took us about a year, and we'll get into a little bit of that in a second too. The approach I wanted to take though is something that I learned from watching the last space shuttle launch. So anyone here ever seen the space shuttle launch like on NASA TV? You ever watch their process? NASA is like the master of choreographing run books across multiple teams. And where they have hundreds and hundreds of people with like to the second precision on their tasks. I had like 3, but I needed that same level of precision. So I took some guidance from how they structure their launches to build out a run book, and then realized that where I only have 3 people, we had to substitute automation for warm bodies to help with the cutover. Okay, so we started the automation process by using Terraform to deploy our file system. Everything we do at Direct Supply in the cloud, if it can be terraformed, it should be terraformed. So FSX was no different. And we knew that in addition to this monolith, we had a few other file systems that we're going to need to move out there. So instead of just building a one-off set of code, we built a module, a Terraform module that would allow us to build multiple file systems using the same underlying code. So if you look at the code here on the left, that's really all we have to pass in to the module to get an entire file system stood up, joined to the domain, and have everything provisioned exactly the way we want it. So that includes, you can't really see the arrows there, but so availability zones, we were using 2 of them because we wanted the high availability FSX design. And then it auto joins our Active Directory. It creates and populates our admin groups, enrolls it in AWS backup, and sets up all of the DNS and routing that we're going to need to do to make this file system become the monolith. And then we can repeat this and reuse this for every other file system that we move out there. So we've got 5 more that we've already done. We've got a handful from on-prem that are going to follow the same pattern using the same module as well. So that was our first step. The second step was we had to automate data sync. Is anyone here familiar with data sync? Have you worked with data sync? Okay, a few of you. All right. So data sync has a few different components to it. You have a source location and a destination location, and you set some copy parameters in there to create a data sync task. Then you create a data sync agent or a group of agents, and that's really the compute behind your copy task. So in this case, our source location was our old cloud file system. Our destination was FSX. And then we started off with a 1-to-1 ratio of, or a many-to-one kind of architecture of many tasks to one agent. And then we had some areas where that worked. We had some areas where we ended up with many agents for one task. But in the end, when we automated the data sync stand-up, we also created all of the tasks that we needed to roll back if something happened. So going into the night of the migration, we were all set with all of our data sync was running from the old location to the new. But if something went wrong, we had to be able to get from the new back to the old. So we let the Terraform automation take care of that for us. Now, I'll say this too, we started hoping that we could get this entire thing copied with like 8 or 10 data sync tasks. In the end, to hit our performance needs and to get our maintenance window as small as possible, we ended up carving things up into 150 different data sync tasks for the rollout and 150 for rollback. So it got very big, but it scaled very quickly and easily. The Terraform is largely copy paste, and we could deploy the entire environment very, very rapidly. We also found that by scaling it up as much as we did and scaling it out as much as we did, that we were able to drastically improve our parallelization of the copy tasks. And that helped us get a much faster migration as well. Okay, so I'm going to break the migration down into 3 phases. We have the migration prep, we have the actual migration itself, and then we have the rollback information or the rollback automations on the off chance that we needed them. So some of the tools that I built, and all of this is open source. I'll give you a link to it at the end of the talk. So if you want any of my tools, you're welcome to them. I drove everything off of groups of data sync tasks. But in order to figure out what tasks I could run at the same time or kick off at the same time to really maximize efficiency, I had to build a task that I called the get runtime. And this goes out and checks all of my tasks, all 150 of them, and tells me how long they're taking to run and how frequently they're running. So we can look at that data and figure out, okay, these 5 tasks can all finish within an hour. So we could run those all together and then stuff some more in there alongside of them. Then we needed a way to check to make sure all these tasks that we're running are healthy. So there's a get status task that I wrote, and that goes out based on these groupings of data sync tasks. And it'll tell you how long did the last task take to run and was it successful or not. So that way, leading up to our migration, we knew where our pain points were and we fixed any like data integrity issues that might be there. How many tasks was something I wrote to please my boss. He kept stopping by and asking how many tasks and how many agents we were using. So that's just a quick little script to give him an opportunity to answer his own questions without bugging me. And then the last thing we needed before the migration started was I needed to eliminate all of the schedules from all those 150 tasks, because I wanted to make sure that once we took our maintenance window and started, took the file system offline, we had 100% control over what was running, in what order, and when it was going to run. So eliminating all of those task schedules was critical to that level of control we needed. Now, this task, and you'll see it in the repo here that I've shared, this task also backs up those schedules. So if something goes wrong, we can restore those schedules easily and get the data back up and synchronizing. Like if we had to set up for a second attempt at the cutover. Okay, now for the night of the migration, about 2 hours before we started, we ran a script that I wrote to stop all of the tasks. We didn't want anything running outside of our control. So anything that was running, we killed off. And if this is something you're looking at doing yourself, one of the gotchas is that you have to kill off the in-queue tasks or the pending tasks first before the running tasks. Otherwise, you're just going to perpetually play whack-a-mole with the next round of tasks starting and starting and starting. DataSync has an option to preserve deleted files. So if I have data at my source, I copy it to my destination, and then I delete it at the source. Well, I don't want that hanging around my destination as long as we haven't officially cut over yet. But we knew that some data was going to have to trickle in after we went live on FSX. So we had to manipulate those tasks so that if there was something at the destination that didn't exist at the source, it didn't blow that away at the destination. All right, then we get down to the nitty-gritty of starting the tasks. And like I said, we had groups of tasks and we had a very set schedule. And this is where we get to that NASA level of precision. We knew how long each task was going to take. So we could say, okay, this group of 5 tasks is going to take exactly 45 minutes to run. And we can start that and then say, okay, and I can start the second group without any impact or, collisions. And that's going to take an hour to run. So then I can go forward in my calendar and say, okay, now I need to validate those tasks. So we run a command, we start the tasks, and then we run a command when we know that job should be finished to validate those tasks. And this is what the output from that looks like. So it tells you the task, make sure it was successful. And it gives you the start time, which is really important because if not all the tasks had kicked off yet, the start time would still show like yesterday's date. So it was important to make sure they all started within the window that we thought they started. Now, if I were going to build this out more and make this, a full-time gig maintaining this code, I'm sure that the start task by group could be tied into EventBridge somehow, and you could trigger alerts that would then kick off a validate task Lambda that would then give you the information you want. I just didn't have the time to cable all that up. All right, now, if things went bad and we had to roll back, we needed some tools that would, again, stop all the tasks. And then because our data sync module created rollback tasks, we had scripts that were able to identify those rollback tasks and run them in the same order that we ran our rollout. See, the thing is, we have some really mission critical data on this file system, and that had to be copied while we were offline. The rest of the stuff, like office documents and pictures of random campus events, those can flow in after we're already live on the new file system. Anything that changed in the last 24, 48 hours, no big deal if that takes a few hours to synchronize. But for the stuff that we need to move during that outage, we needed to have the same level of control over those tasks so that we could get as efficient a rollback as possible. And again, we had to validate those. So it's pretty much the same tooling for the rollout, just updated to manage the rollback tasks. After the rollback would be done, we're going to need to restore those task schedules. So we deleted them earlier. That outputs a CSV. This task will pick up that CSV and roll those schedules right back out to all the tasks. So once your rollback's complete, you can get back to the business of setting up for your next attempt at the migration. And again, just the opposite of the deleted file script from the night of migration. We'd want to put that back if we were going to have to roll back and take a second shot. So all this worked really, really well. We were able to successfully migrate. We expected about 16 hours to migrate, and we were done in less than 12. So the fate smiled upon us for this migration, and all the automation running and all the tooling that we built meant that with just 2 engineers and 1 member of SRE, we were able to get the rollout done. And then our test engineers were there to validate after we rolled out. All right, so a few lessons that I learned from this process. Number 1, know your data. So if you don't know that you've got 1 billion 1K files, one data sync task is not going to cut it to move that data. So you have to understand where you're likely find your pain points and make sure you're architecting data sync to address and account for those. And then with the automation, it doesn't matter if it's 1 task or 20 tasks, you can make a very easy pattern for rolling those out and getting those run on your schedule. Number 2, don't be cheap. So our migration to FSX was strategic. We knew we were doing it, but it also came with a big cost savings. So moving to FSX, we saved about $300,000 a year in hosting this data. So we wanted to make sure that we weren't going to spend a ton on the migration and undermine the savings we were hoping to get. And so I made the mistake of undersizing the throughput on the file system and oversubscribing our bandwidth in the tasks. And that was leading to tasks taking days to run when they should have taken minutes or tens of minutes to run. So scaling up the throughput on your file system is critical to doing anything with data sync. And then just making sure that your tasks are getting enough resources with their agents and making sure that you have the right size agents to be able to move your data correctly. The other thing on scaling up throughput is, and they tell you this in the console if you do things through the console, but you never see the errors if you do it through Terraform. When you go to expand an FSX file system, if your throughput setting is anything less than the max 2 gigabytes per second of throughput, that operation to grow your file system can take weeks to balance out and level out in the end. And that means you can't do anything else to your file system, like change the performance dynamics or grow it again. If it's rapidly filling up, you're stuck waiting for your file system to level out and rebalance. So scale up your throughput before you do anything to your file system. That's critical. Even if you're after a migration and you want to add 5 terabytes to your file system, bump your throughput to the max, and then your grow finishes in like 45 minutes. So very critical lesson. All right, next thing we learned, SMB session caching. We were a little bit naive and thought that if we took down the DNS entry that had a time to live of 1 minute and killed that off, the things that we're talking to it would suddenly lose their connection and sit there waiting, retrying the DNS entry for the new A record that was going to replace it. That didn't happen, and some servers just kept their connection. So we found after the migration, we had a bunch of servers we had to reboot. So my next recommendation here is just shut down any hosts that are going to be talking to this data to make sure they're not changing your data unknowingly. It'll make your headaches a lot fewer when you come up on the new file system. All right, seed your rollback was another good lesson we learned. The first copy that data sync, or first time data sync runs a task, it's a full copy of your data. So if you don't take a bit of time and seed that rollback to at least have the full out of the way, you cannot get away with running an incremental to move just change data back. So if I had to do this big migration all over again, I would have paused and run my rollback scripts and my rollback commands and tasks before the night of the migration. So I at least had a foothold on a rollback. So it was incremental instead of full. Especially when you're dealing with 20 terabytes, that can take days to roll back. All right. And then the last thing that I learned is more about code structure here. But we had one repo that included our calls to the FSX module and our calls to the data sync module. Now, the data sync module is creating that task that has a source and a destination, and there's also some logging thrown in there and some security groups thrown in there. So for every one task we created, we had 5 objects that Terraform had to tear down. So at 300 tasks, that's 1,500 objects that are getting destroyed. And then you also got the agents and their security groups and their policies that get attached to give them access to the data. So you end up with thousands of objects in Terraform that are getting torn down when you just try to get rid of the data sync tasks. We had so much in our output because there were so many tasks that I actually wrote a parser to go through that Terraform output and highlight anything that was being destroyed so that we could just scan through that list quickly without reading all of the extra details Terraform provides. Because the last thing we wanted to do is accidentally tear down something that is needed for our file system when we're just trying to clean up the data sync tasks. All right, so there are links to all of the code that I used for this migration. If you hit the QR code here, that'll take you to a list of all my links, and you can get all the scripts right out of that repo. And feel free to do with them as you need to. Otherwise, if you have any questions, I'd love to take your questions. Yeah. So I would chalk that up more to tribal knowledge than running a formal classification project. Ultimately, we agreed as an organization that this would be the last time we rehome this file system as one giant monolith. And we probably wouldn't have done the move to FSX when we did if there wasn't a nice juicy cost savings out there. We wanted to save that money so that we could reallocate it towards resources to actually focus on splitting this file system up into individual buckets of data on their own discrete file systems that are managed by the appropriate teams. Like right now we have, order processing data sitting on the same disk as, pictures of a company picnic, right? And so when we're dealing with AWS backup and the way you restore FSX, you restore all of it to restore some of it, right? We turn on VSS backup so we can get some individual file level stuff. But in a disaster, right, we're going to be handcuffed to restoring all of our data versus just little bits of it. So we moved it with that being the concession we made for now, knowing that our next step is we're going to get away from that monolith restore going forward. Any other questions? Yeah. Yeah, no, there is no DFS in play right now. When this file system was born, DFS wasn't really a thing. And we have, the namespace is critical in the org, right? Like everything knows to write to whack file server name. Whether that's an application, whether that's an end user, logging scripts on a laptop, all of that writes there. And by the time that DFS was ready for prime time, any movement into DFS to try and make this easier would change. You'd have to have it in Active Directory for high availability. And then it becomes file server dot domain name dot everything. And you have to use that FQDN. And because there was a lot of data and a lot of process that existed before that was the standard. Shoehorning that in would have been, I mean, we have 25,000 code references hitting this file system day in and day out. So it would have been a massive undertaking to just, you know, Control F, Control H, you know, that would have been ugly and break a lot of stuff. So we've looked at other ways to do that. There were some third-party products that you could slide in without breaking the namespace, but before we could even get a purchase order together, those products were off the market and deep sixed. So I don't think we'll pursue DFS going forward either. As we break this up, we'll break things up into smaller, more application-focused file systems where the high availability of FSX will be adequate for what we need, and we're not going to need to ship a namespace around the world. Yeah. 100% of what we deploy in the cloud is Terraform. So, and anything we're going to do more than once, we try to build modules for and try to make sure that we've got highly reusable code. So we had, in this case, the Terraform was for all of the tasks, all of the agents, the location, source, and destination, the rollback tasks, all of it was 100% Terraform. Yes. Yeah. Yep. Go for it. We will likely not pursue FSXN. It's just not a good fit for all the tooling that's already running in our environment. But that said, not all of this data will continue to live in a Windows file system world. There is a ton of this data that would live perfectly fine in S3 and actually give us new capabilities if we were to, you know, make that S3 part of a lake that we could then, you know, run queries against and survey the data differently. So, yeah, and probably some of this data is going to go into like Office 365 or, you know, other managed services. The goal is I don't want to have to manage any more platforms than I absolutely have to. I hate patching. I hate midnight maintenance windows. So if we can get that farmed out to managed services or get it to places that just don't have patching cycles, that would be much better. And S3 is going to handle 1 billion 1K files way better than a Windows file system is going to handle it. So, yeah. Got any more? Yeah. Not yet. So everything that's hitting this, or almost everything that hits this file system, is in cloud already. We had some applications that were highly sensitive to latency, especially like application to file system stuff, and then application to end user compute. So we actually run about half of our company out of Amazon workspaces. So our latencies are really nice and low. Everything's running happy. I have some other data sets that live on-prem still that are tied to incredibly latency sensitive applications, like you know, AutoCAD, some 3D rendering stuff, all of our creative teams that handle all the artwork for a 2,000-page printed catalog. All that data needs to sit as local as possible to the end users. So our plan is that after we get through a few more projects that we have in the pipeline, those gateways are coming in, and the gateways will then act as the on-prem local presence for that data that'll then be mastered in AWS. The data is already data synced. It's already copied out there and ready to go. So if something happened to our on-prem data center, we could update DNS and say, you may have lost some data, but here it is. Enjoy the latency while we get this fixed out. But that said, I've also beta tested the appliances. If you look on the AWS storage blog, I have a post that goes into detail about all the performance testing I did like beating them up and comparing their appliances to our on-prem NAS and looking at what those performance variances look like. And I can't wait to get those gateways in. Way more cost effective than a NAS lifecycle. Yeah. Any other questions? Cool. All right. Well, if you have anything more you want to follow up with me on, all my socials are under here, my email address, all the code for the talk. If you want to learn more about AWS Heroes, I'd love to talk more about that too, and AWS community stuff. So thank you all for coming, and please come find me later if you want to chat more.
All right. Hi, I'm Kathy, but you guys know that. This is how to conquer LinkedIn. All right. So first question, get asked all the time is why LinkedIn? One is you're adding value to your professional relationships and you're expanding in concentric circles your network because your connections get notified when you do things. So their connections get to see what you do too. There's LinkedIn Pulse. I think they've kind of de-emphasized this lately, but you could actually get spotlighted by LinkedIn itself. And the potential reward far exceeds the effort. This takes 5, 10, 15 minutes a day. And it positions you as an authority on your topic, or if you're a performer, as somebody that they need to cast. This is what I hear a lot. Like people make excuses about it. Either it's, I don't have time. My posts never get any traction. Like I tried that once, right? And it didn't work. I think the big one is either who am I? No one wants to know what, I have to say about things, or they just don't have any place to start. So just to address that, it's all probably a lie. And usually it's a lack of a plan, or you're a little bit afraid of it to put yourself out there. So some strategies I found that help is to time block your calendar, right? So every morning, 8 to 8:15 or whatever your time frame is, or maybe over lunch, like noon to 12:15, like I'm going to take that time and deal with social. I've got step-by-steps for you, so you could follow that. I like to give myself a little reward sometimes. That might be chocolate, that might be bourbon, whatever floats your boat. Another strategy is to try not to break the chain or the train. People call it either way, but basically like every day give yourself a little checkbox, right? And you don't want to break that string of, oh, I've got 10 in a row, right? I don't want to miss today. Shift your mindset about it. It's not like a chore. It's something very good. It's helping to advertise you and your business. Another one I like is habit jacking. So take something that you really, really enjoy. Like for Dave and I, that is definitely coffee. So when I have my coffee, that's my social media time. So couple that up with something that you really like doing. As far as posts not getting any traction, it is nearly 100% lack of consistency. Okay. So if you post, even if it's twice a week, just be very, very consistent about it. The algorithms like it, the audience likes it. For instance, I have this really great YouTuber I follow, and I know that 11 o'clock on Sunday is when she puts that video out. And if she doesn't put it out at 11, I'm bummed out. Like my whole day is totally off. And believe it or not, people will get to that point with your content. And then the other thing is people just try to sell, right? They're like, they take their company post and they reshare it and they don't add anything to it. And I'm like, do you like reading that stuff? Probably not. So this is one I really hate because I hear this all the time, and I thought it myself. I'm at about 5,000 followers right now. So I'm like, in and out of it, but it was always like, I'm a nobody, like, I didn't graduate top of my class at Harvard, or, I'm not the CMO of a Fortune 500 company, but everybody in this room has valuable info. Like, don't care who you are, what your specialty is, like, you've got something people want to hear about. The other thing is, now we've got AI tools. Like, please don't go to ChatGPT and say like, write me a 25-word post on blah, right? Like that's not adding value. So part of this is you being able to withdraw from the relationship bank. So you've got to put deposits in, and that's adding value to your network. So I don't know where to start. So here's my little step-by-step guide. And I am not going to play the step-by-step song that I did have in this, I don't think. All right, we'll see. I don't know if it's going to work on here. I know. All right, I'll try. If it comes up, I'm going to do it. I know. Okay, so if you have paper, grab that. If you're a laptop person, grab that because this is going to be an interactive session. So what we're going to do, we're going to decide on the topics and our cadence. We're going to create a posting plan, and y'all are going to stick to it. We're going to gamify it to make it a little bit more fun, and then we're going to talk a little bit about the rules of the road. Oh, it may happen. No. No, I took it from Google Slides, so it didn't come over. What a bummer. Step by step. Ooh, baby. Okay, let's get out our pen and paper or our laptop. Okay, first thing I want you to do is write down 2 to 4 things that your audience is interested in. So if you're a DevOps person, maybe you want to talk about like containers and Kubernetes, or CI/CD pipeline. It may be that you're at a certain type of business and people want that kind of content. So give me a second here. Yes. Ooh, that's a good question. Do you have an established audience right now? Arguable. Okay, so let's pretend you're starting from scratch. Then I would go with what you want them to be. So, you know, if your audience is developers, or maybe you're in sales and you want it to be CTOs, CIOs, then I would write the content that way. All right, how's everybody doing on their 2 to 4? Getting there? Good, 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 good. All right, next thing I want you to do is write down 1 to 2 things you're passionate about. They don't have to do with work even. Ideally on LinkedIn, it would be sort of a work topic. Some examples there might be, maybe you're passionate about return to office and remote work. Or I have a feeling Margaret is in the same boat, but I have kind of an obsession with project management tools. So like that would be a thing I could talk about. Maybe you're into rescuing cats and dogs, like something to more, this is to round out your post and make you look a little bit more human and relatable. So, all right, thumbs up if are you through your 2 to 4 and your 1 to 2? You do not look like you are. Okay. Okay, excellent. Okay, next, was that a, oh, sorry. It was okay. All right, and then write down how many days it is reasonable for you to post. So again, if you're combining it with another habit, like in my case, like I said, it's coffee. Like I wake up, that's the first thing I do, and then usually about noon I have a cup of coffee. So those are kind of my social media times. So if you're coupling it with, I don't know, maybe you're super into the gym or something, not something I personally understand, but you know, maybe on your gym days, is social media, right? So I would say for LinkedIn, you probably want this to be a minimum of 2. All right, we good? You guys are all so quiet. Okay, that's not a bad thing. Okay, now we're gonna draw a little grid. So you can make this 4 rows, 5 rows. I usually like doing 5 for the extra week, you know. No ChatGPT. Everyone gets 3 ChatGPTs a day, and that's it. You're cut off. Okay, so I want you to take this little grid, and remember we came up with 2 to 4 items for work and 1 to 2 passion things. So I want you to sort of plot them out along the days of the week, and kind of think about what makes sense, right? If you say you work in staffing, right? You're a recruiter, you probably want your posts on Friday, Sunday, right? By Sunday, people are like, I don't want to go back to work tomorrow. I'm looking for a job. If you don't have a situation like that, I usually put my passion stuff on Friday, just a little bit more fun. So your work things, I would post about every week. If you've got 4, in this case, I just sort of bounced them around, right? So you're hitting all the topics. So you can see we've got, I took the number 1, number 3, number 2, number 4. But if you just have 2 items, you could just maybe go 1 and 2, 2 and 1. Yes. You like to schedule stuff? It's the way to do it. Yeah, some people like to batch it, right? Like if it's not your gig, but you know you need to do it. Yeah, 100%. And by the way, LinkedIn now has a built-in scheduling thing. I think everybody has it. So when you go to post, there's a little clock on the bottom, and you could actually do this on a Sunday. Do it for 2 weeks, like you're good to go. Yeah. For tomorrow, yeah. There's some good tools though. It's harder and harder to find free ones, but there are some good social media management tools. And you're using HubSpot, right? Yeah. Run it out of HubSpot. Oh, yeah. Well, for now, you could do it right in there. Just even your personal account, you could hook up and then just schedule it from in there. Yes. Yes, most of your social media, including HubSpot, you could tell it to post to both at the same time, but you run into the limitations, right? Like the images are different and the word count. But I think Hootsuite still has a free plan, so that's a good option. All right, now we're going to gamify it. So the most valuable thing that you could do is to post your own content, like with your own stories, right? That's number 1. So you could give us different point system, whatever you feel like, but in this case, we'll do 50 points, right? So next thing you could do is share an article from someone else and add your own commentary. This is a big mistake I see. Like people will share their company stuff and then just hit post. Like you're really not doing anyone any favor. So just add a line or two, like, this was the coolest conference I've ever been to, and Margaret is the best person ever. You know, just a couple of lines. So it is. So we're going to give that 20 points. The next level down would be leaving like really substantive comments on your target audience's post. So that's not like, hey, great post, good luck, congrats on the new job. These are not substantive. Like, give it a little bit more. Oh, I was like, okay, I'm sorry. It's like, I probably need more coffee. Okay, so we're gonna go 10 points for sharing something without commentary. I mean, every now and again, right, there's just nothing to add. Like today we put out a press release, I shared it and went, right? 10 points for thoughtfully easy for me to say, replying to comments. So if you're gonna do this and you're gonna get that effect of like, you're posting something and then your connections like it or comment on it, and now their connections are seeing it, it's a wasted opportunity if you don't respond to everyone. So if someone takes the time to make a comment, definitely respond, either even just a thank you or a like or just something to acknowledge that. 5 points for just liking something. 5 points for liking comments on your own posts, again, because that's not as, you're not putting as much in the relationship bank as actually acknowledging it. And then 5 points for just liking random stuff. So your goals here, this guy, because I can't see it. So beast mode, if you get 100 points. So as you can see, you could do that by doing 2 original posts or by leaving a bunch of comments. But agree to 75 points. Good is 50, and then keep pushing is 25. That's a needs improvement. So I do want to give credit. This is not my idea. Erin Saris and one of my marketing groups came up with this awesome idea. All right, so some guidance. I'm a different person when I post. Like, I just kind of step into an acting role, right? And like, I know what I'm talking about, and I'm big and brave, and I post something, I hit the post button, and then I kind of go, oh God, what did I do? But sometimes that's helpful just to like put on kind of a persona. If you're a servant and not a seller, you're going to be very successful with this. So just think, is it something you'd want to read? Be authentic. Like, so do step into a role if it helps. But don't be one of these people that, like, do you guys know what broetry is? So broetry is those posts that you see on LinkedIn where people are like, she said no to the job offer, period. Next line. And they're just like single sentences like this long. Like, don't do that. Build a content library. Like I said, use Hootsuite. That'll help you get ahead on things. The other one is just don't be an asshole. And that's that person who's taking from the relationship bank instead of putting in. It's fine to ask your audience for things, but I would go 10 posts, 7 posts, like put enough in that they feel invested in you. They're like, oh yeah, I'm going to do this for Dave. Like, he's giving me so much valuable stuff, right? Do not pitch slap, please. Everybody know what it is? Yeah. So pitch slap is when, you know, somebody likes or follows you, they send you a connection request, and you're like, I don't know, you take it. And then 5 seconds later, it's, boy, have you thought about, you know, we could drive leads to your website and blah, 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 blah. So don't do that. Mixing up your content is good. So the algorithm likes you bouncing around a little bit. So maybe you post a video and then, you know, just a couple of text things, and then do a graphic. And using a minimum of 3 to 5 hashtags work. Don't do any more than that. Then that looks super spammy. All right, and then extra credit. I think these decks are going out, right, Margaret? So that link will be live. It is an amazing guide. It's like 50 pages. Tool-wise, if you're not familiar with Canva, it's maybe the best software next to OneNote ever created. And like I said, look at some social media tools and turn on creator mode. So you'll see that as an option in your profile, and that gives you some additional functionality, including things like being able to live stream and trying to think what else. The scheduling might be connected to creator mode. I can't remember, but there's definitely some advantages to doing that. And that concludes my talk on how to conquer LinkedIn. Thank you, guys.
I just want to amplify.
That's fine. Do you guys keep a leaderboard of your crew? I think that helps. Yeah. Oh yeah. Yeah. Yeah, it honestly, as a marketer, I like, I'm happy when people share things, but I really wish they'd just take a moment and just add a line or two. It doesn't take much. And it adds, because then what happens is something goes out for marketing, hey, can people share this? And then if you have similar audiences, people are annoyed by it because now their whole feed is this same stupid post. So yeah. All right. Anybody have any questions or additional thoughts, things that are working for you? You could do 2 things. So you can actually put that long form content on LinkedIn. The upside of that is kind of the viral nature. You know, it could catch on. Downside is that's not doing anything for your SEO. So I personally think that where things are going, I think blogs will still be valuable, but I think generative AI said it, is going to change things. Because now, you know, like, why would anyone read that when they could just go to Chat GPT and generate it themselves if they were like, everything I ever wanted to know about blah. So I think video, strong opinions, and interactive are really the thing. So I would honestly, like, a blog is good because it'll drive SEO value, but I think having a YouTube channel is even better. And then if you want to talk later, there are a lot of ways to repurpose that content. So you can do the video first, you get the transcript, and then you take that transcript, break it out into like 10 different social posts, and then you could clean it up and make a blog out of it. So I'm huge about like making the effort once and then reusing it. Yeah. They claim they don't. And yeah, they claim they don't, but they do prioritize video. And I would say the other thing, so YouTube is all, well, let me backtrack. YouTube is the second biggest search engine. People don't think of it that way. Anyone under 50, if it's how to, they're going to YouTube. Secondly, it's got its own SEO. So throwing video up there isn't enough. Like, you need to really think about the headline, think about the description and the keywords, and look at all that too. Yes. Goes in cycles. Yeah, so every once in a while, like, I think it's starting to fade, but for a while there, putting the link in the first comment, so putting your post out there and then commenting on your own post with the link was working. My opinion is provide a good customer experience and people will go, right? Like, if the algorithm deprioritizes that, there's nothing I could do about it, but I don't want to make people look for the stupid link. Like, just make it easy for them. That's my opinion. Howdy. Anything else? Thank you, everybody.
I've never been to as big a community event as this. I'm out from the West Coast, based in Seattle, but this is extremely, extremely impressive. All right, well, I'm just going to dive in. Hi, guys, I'm Mark. I work at Couchbase. We're a NoSQL cloud database platform with specific and particular strengths in mobile and edge computing. So I'm really excited about today's topic on edge computing, and I'm going to be focusing on how edge architectures can actually, when appropriately applied, can enable highly resilient and fast applications that work everywhere, all the time, guaranteed. And that was actually one of the leading requirements for some testing that we actually did. So we'll get to the fun stuff, but first, what is it we're going to cover? Three main areas. First is the need for edge computing. I think we can all say that we know what edge computing is, but it's one of those things, the phenomenon where you ask 10 different people, you're going to get sort of 10 different answers, and they're all right. In fact, that's the amazing thing. But we'll talk about the need for edge computing, what it is, what it enables, why it's necessary, and where Couchbase fits. Then we'll get into the fun part. I'll talk about the ASC or ASC edge architecture. That is an edge architecture built with AWS Snowball, SpaceX Starlink, and Couchbase Capella. And I'll also cover the results from tests on this architecture, where we tested for latency and bandwidth efficiency. I'm going to begin by setting the stage for edge computing. What is it that, what challenges does an organization face that makes them actually seek out edge computing? And the interesting thing is, generally, we find with our customers, they don't ask for edge computing. They come to us with specific problems. So let's take a look at some of those challenges. So first, let's consider an offshore oil platform in the North Sea. And it has 3 or 4 control room operators. This is very typical for most oil and gas companies. And they're continuously being fed tons and tons of data from sensors that are all over the platform. Above water, down hole, platform. They have to control a multitude of variables, each with different settings, and at the same time consider things like temperature and wave height and humidity. And there's so much information that's coming so fast that operators, in fact, when McKinsey study proves it, they actually slow down production to reduce risks and hazards. And it becomes a barrier to efficiency that companies just can't overcome, especially when their on-platform apps require data processing that happens in the cloud. So suppose you need to analyze some sort of critical reading, warning data from a pressure sensor. And if that data needs to be processed in cloud data centers, it has to travel really incredible distances in the middle of the North Sea at great expense over unreliable networks. And this incurs high degrees of latency. And that's network slowness, a bad thing, especially for these types of apps. So by the time a result ostensibly is sent back to the platform, it could be really too late to take any action. So what's needed really is a way to keep up with this deluge of data at all times on the platform without having to rely on the cloud and the internet. Next, consider an airliner. This is where great customer experiences are the best competitive advantage for any airlines. But it requires really providing a personalized experience for passengers and making onboard processes as fast and efficient as possible. So to do so, it's really imperative that cabin crew, they all have fingertip access to data, the information on each and every passenger. And that way they know that they always know that they can, sell current inventories for meals and amenities and duty-free items. Orders can be fulfilled immediately. No one buys a sold out item. Ready access to data is really key to doing all this and a key to delighting passengers. But if that information that is actually feeds this experience is in the cloud, this becomes a barrier when in flight. How can an airliner provide that personal experience without a reliable network to leverage? So what's needed here is a way to access passenger data and inventory data and other types of data instantly without relying again on the internet. And then finally, let's consider a cruise liner that wants to enable things like hyper-targeted marketing through on-vessel applications. Doing things like making recommendations and offers in real time to guests that lead to upsell. Like, hey, we noticed you have the same Chardonnay, a glass of Chardonnay every night with dinner. Here's 20% off coupon. Why don't you take a bottle home with you? That's a win-win for both. And imagine if every passenger, spent just $100 extra more on their journey. That's a potential for hundreds of thousands of additional revenue on each voyage. So that the motivation is really high. But this concept relies on the ability to capture guest data at all time, right? To know where they are, what they're doing, what they purchase, when they go to specific places. And that's how you build that guest profile, provide this type of experience. But the problem is guests are pesky. They're all moving around the ship and the ship is moving around the ocean, right? And when internet is slow and unreliable, this presents a big challenge. So because of cloud data center dependencies, this exacerbates that particular challenge. So what's needed here is a way to process and react to changes in guest data in real time, again, without relying on the internet. So networks here, that's the common theme, become kind of a bottleneck when you think about it. So these use cases are not isolated, right? They represent this growing class of apps that require 100% uptime and real-time speed all the time, without question, regardless of internet connectivity. So edge computing provides that answer, right? The goal of edge computing is to bring data and data processing and computing closer to the applications that consume it. And to do so, you need to do things like embed a database to edge clients, and that reduces dependencies on the internet. And you need to synchronize data across the edge, from the cloud to the edge of the device for consistency. And that model speeds up applications because data doesn't have to travel all the way to the cloud and back. And it makes them more reliable because local data processing removes internet slowness and outages from this equation. And it can also handle privacy better because sensitive data never has to leave the edge. And finally, it promises more efficient bandwidth usage by lessening the load between the cloud and the edge, because now the cloud database is no longer the primary source of information to power these applications. So it's kind of one thing for me to describe an edge computing architecture, but let's dig in a little bit deeper and see how one actually works. So here's a simplified cloud compute architecture, right? We're leaving names and vendors off just for the case of simplicity here. So in the cloud tier, we see a web application and the database that feeds it deployed, let's say in the US West region. And then at the bottom, we have a client. And let's say in this case, we're in San Francisco. And it could be any edge device, right? Phone, tablet, IoT device, custom rugged device, that kind of thing. We're just representing it with a phone here for simplicity. So in the cloud model, the client accesses the application over the internet with all of those inherent hops and latency. If the internet slows or the cloud data center ever becomes unavailable for any reason, apps will suffer latency and downtime. And for specific cases like those in healthcare or defense or the ones we just described, these are just showstoppers. Can't lose that application. So all those limitations can actually present barriers to meeting the requirements of these modern mobile applications. So edge computing solves for these issues by adding kind of this additional layer of compute and networking. And we're just for simplicity's sake, doing 3 layers. But imagine, if you will, you can do as many layers as necessary to meet the needs of availability and low latency for applications. So we've introduced an edge zone in the middle as an intermediate tier to the edge. In this case, running, let's say, in a local zone in San Francisco. We've also added a personal area network in the client tier. So let's see how these layers can all work together in order to serve clients in San Francisco with ultra low latency and higher availability. So first, within the new architecture, we duplicate the web front end and database, then redirect the client to the web app and database that's running at the edge. And then we connect the edge data center and cloud data center via synchronization, right? Synchronization is a key for consistency. Now, if this is a global application, let's actually start to expand the aperture a little bit. Here we want to make it available across multiple cloud regions. We duplicate the original regional zone and edge zone resources to the additional region. Let's say in this case, the East region. And we duplicate the web app and database from the original region over to the new region. And then we connect the database from west to east via synchronization, right? So now what we're looking at here is a full edge computing architecture that spans multiple regions, serving clients in specific edge zones with hyper-fast responsiveness and local computing power, making those applications go faster and more reliable because they're not so dependent on the internet above. So now let's make things a little more interesting. I'm going to introduce another area, new city in the client tier. Let's say LA. And unlike San Francisco and New York, let's say this city doesn't have an edge computing region. In these cases, the client can still connect, to the West services and database. And making things even more interesting, I've started throwing additional clients in Los Angeles. And to illustrate another way that we can actually solve for edge computing for local data processing is put the database directly on the device or embedded to the applications that are actually running on the client tier. And then we can sync from the embedded database to the cloud data center and ultimately back down to the edge data centers, keeping the entire data ecosystem up to date. And finally, sort of leveraging this personal area network, we were able to also facilitate synchronization between the local databases there. So if the connection to the West region gets interrupted, the devices with the embedded databases can sync between themselves via peer-to-peer synchronization over that private area network. So if data changes on one device, devices running embedded databases. So it's this architecture that ensures the lowest latency, highest availability, and most stringent data governance for applications. So by capturing and syncing data from cloud regions down to edge zones, and ultimately on device. And you can also isolate data with precision anywhere in this architecture or topology to ensure data privacy for applications, right? Again, another fundamental tenet of edge computing is that sensitive data never has to leave the edge. But you have to have a database that actually can facilitate this. So Couchbase is that database. We fit into the edge architecture from end to end. So for the backend database, you can deploy Couchbase in the cloud and at the edge. And for on-device data processing, you embed Couchbase, Couchbase Lite, which is our embeddable version of Couchbase, into the apps that run on the device. And that data synchronization that we see, all those red lines are really the key, stitches the whole architecture together. And that provides vital continuity for this application. So this architecture effectively sort of creates a fabric of data processing, if you will, that ensures that low latency, data integrity through synchronization, and high availability for your applications. So let's talk a little bit about the different pieces. As we saw, Couchbase represented across the architecture, but it's really only 3 pieces that we're talking about. Just think of them as Legos. You can assemble them as large or small as you actually want. So the Couchbase mobile product stack is the foundation of our support for this edge computing architecture and these topologies. So on the left, we have Couchbase Server. This is our flagship modern database server. Even though we're NoSQL, it supports SQL, another huge advantage of Couchbase. It also brings analytics, full text search, eventing, things that our customers no longer have to bolt together from different technologies. Then on the right, we have Couchbase Lite. This is the embedded version of Couchbase that I talked about. It's intended for developers to embed directly into their program code for mobile and custom embedded devices. And Sync Gateway here is the mechanism that sits in between, and that's responsible for secure data sync, as well as routing and access control between mobile clients and server tiers. So it's sort of the traffic cop, if you will. What data gets through, which direction does it go, who can see it? So these capabilities can be deployed in 2 ways. First, fully managed with Couchbase Capella. And this is our database as a service, which has app services and synchronization built in. Or self-managed. This is where customers would install and manage Couchbase themselves on public or private clouds, or on a cloud edge service, or on-prem, and any or all combinations of the same, really. So this is another kind of fundamental benefit of Couchbase, is that you can actually stitch together this entire, you have some self-managed, some hosted, put it together however you need to in order to meet your requirements. So digging into specific topologies just for a second, Capella is available, of course, on AWS in the marketplace, provides hosted and managed database as a service, which is running Couchbase Server under the hood. And it provides fully hosted and managed app services. And this is running that Sync Gateway under the hood. Same technology, just when it's hosted, we give it a slightly different name. So common topologies for app services applications include offline first sync. And this is where apps can work in isolation for extended periods using Couchbase Lite for that local data processing. And when connectivity is available, app services provides the secure data sync back up to Capella over WebSockets-based protocol. Another common topology is peer-to-peer with Cloud Sync. This is where Couchbase Lite is deployed on edge devices. And for that collaboration in isolation, peer-to-peer sync is the feature that's used to synchronize data between edge devices when they're completely disconnected from the internet. Of course, when there is internet available, synchronization happens behind the scenes, ultimately back up to Capella. And then finally, app services also supports mobile and web apps with secure access to Capella via REST. So in this topology, clients can either embed Couchbase Lite if they want to, or they can just call the REST API directly from web or desktop applications. So we've tried to facilitate multiple models here. Many of our customers are employing, combinations of all of these. Just for a second, on Couchbase Lite, it supports iOS, Android, and Windows platforms. .NET and Java apps can be built for desktop and server apps. And we have a C API, which allows developers to build custom apps in C that run on nearly any embedded platform. So think here like agriculture drones or orthopedic surgical instruments, actual customer use cases. They're embedding Couchbase Lite for edge computing. So it allows our development teams at our customers to develop faster because it's JSON document flexibility, simple to use APIs for database operations, SQL support, so they don't have to learn new paradigms in order to adopt NoSQL. and actually adopt these edge computing architectures. So with that background on edge computing, let's turn to a practical application of an edge architecture. So this is the fun part, right? Our engineering team recently decided to see if they could build an application architecture that works anywhere on the planet, whether connected or not, and one that takes best advantage of spotty connectivity when it is connected. So to break down the fundamentals, an edge architecture requires 4 components to deliver on these promises of low latency, 100% availability, and data consistency. The cloud compute environment, an edge compute environment, a network that connects the two, and a database that can take advantage of the previous 3 components. So to fulfill each of these requirements, we assembled the ASC or ASK stack, and it's comprised of course, AWS, world's leading cloud infrastructure provider, AWS Snowball, and this is an edge service from AWS that provides secure, portable, rugged devices that are about the size of a suitcase, an appliance, basically. It's called the AWS Snowball device. And these run AWS infrastructure for powering applications at the edge. One of the original intents of it was to allow for, migration, large migrations from on-prem to the cloud, but we recognized immediately its potential for really remote edge computing. So for the network, we use SpaceX Starlink. This is that next-gen satellite internet service. It's made up of constellations of low Earth orbit satellites that customers connect to, leveraging a portable dish. Looks just like that. And finally, Couchbase Capella. This is that, again, fully managed cloud database as a service. It includes Couchbase Lite and app services for sync, authentication, and access control. So a little bit about the effort. It was an independent test conducted by Couchbase Engineering and intended really to measure the difference in overall response times and bandwidth usage when accessing a web service powered by Couchbase and deployed in AWS US East region versus one deployed on an AWS Snowball device. So the environment, of course, in the cloud, Couchbase Capella and Couchbase App Services deployed to the AWS East region. On the edge, Couchbase Server and Sync Gateway deployed on AWS Snowball. For internet, we used Starlink. And the client was just a plain MacBook Pro on a local area network. So looking at the architecture, AWS Snowball Edge provides computing infrastructure at the edge here on this side. That's the Snowball. Couchbase is deployed on the Snowball Edge device for local data storage and processing. And Couchbase Capella, running in AWS, serves as the hosted backend database as a service in the cloud in the US East region. And Starlink, of course, knitting the edge to the cloud. And Couchbase Capella App Services is doing the synchronization between the edge database and the cloud database. So from there, we actually started conducting tests. We ran 4 tests essentially over a series of days. Essentially first, a write of 1,000 documents to the edge from the client, a sync of 1,000 documents from Snowball to Capella over Starlink, a write of 1,000 documents to Capella from the client, taking Snowball out of the equation, and a sync of 1,000 documents down from Capella to the Snowball device. So trying to really put our aperture firmly on what are the different connection points between these layers. And for the writes, we measured latency. For the synchronization, we measured the amount of data sent over Starlink. All right, drum roll, the results. So we really expected to see, lower latency due to local data processing, right? The data is closer, but it was really substantial. Results showed that the edge architecture reduced latency by 98% as compared to the cloud architecture. Again, of course, that makes sense. In some of the tests, the client is sitting right next to the AWS infrastructure on that device, much less distance that the data has to travel. But we were super excited to see the reduction in data sent over the Starlink network for data synchronization. And this is because 42%, because of efficiencies that are enabled by synchronization, like cross-record compression, delta sync, batching, filtering, all of these things that come part and parcel with our sync, including restartability, all of these things. Through this, the edge architecture makes the best use of that shared bandwidth. So syncing updates over the edge architecture reduce the amount of data transferred over Starlink by 42%, as opposed to using just plain REST calls up to the cloud architecture. And this is really, I mean, it's a fantastic result, but really great when you're talking about Starlink, which is critical because Starlink is shared bandwidth, right? It varies greatly in speed and availability depending on when you use it. From hour to hour, it can change because they're literally going around the planet. And while 42% is good, we actually think that this is conservative. We think continued tests under heavy load would actually show an even greater reduction in bandwidth use because of this notion where you only sync the bigger chunks of, let's say, a catalog once. And then from there, it's just incremental changes, price change, 1 or 2 items, these kind of things. So, why did these numbers, why do we see these numbers on the ASC stack? Because the stack reduces the amount of data sent over the network, due to the fact that sync data is highly compressed and brings with it all of those other efficiencies I talked about, cross-record compression, delta compression, batching, etc. And the stack makes apps perform faster because the local data processing, right? Simply put, there's less distance for the data to travel, and so we see much lower latency. So this stack, in similar topologies, we think can support a vast array of extremely remote edge computing use cases. So let's bring the presentation, as we start to wrap up, let's bring the presentation full circle back to the use case challenges we started off with, right? The oil platform can process and analyze data by leveraging on-platform edge data centers. The Snowball device and with running Couchbase. And it can sync data to Capella in the cloud via Starlink, but when that network goes out, that's okay. Our synchronization is smart enough to know, oh, hold on, it's getting slow. Oh, it stopped. Just keep the local processing. And it detects when that network is back and starts to synchronize again. So it takes all of that off of the developers to have to figure out and build into their applications. So, this keeps apps available and fast for the platform operators. And for the in-flight airline apps, same story. Thanks to the in-cabin data processing and storage, the crew gets immediate access to passenger profiles, preferences, meals, amenities, duty-free items are never oversold with this model. And it helps make the customer's experience as personalized and comfortable as possible, which leads to loyalty and repeat business. Super important for the airlines. We have many airlines that are our customers, by the way. And finally, for the cruise lines, the ASC stack can provide the means for capturing the constantly changing guest data while at sea and using it in real time for offers and recommendations that lead to better guest engagement. And the paramount thing, the all important upsell for the cruise lines. Some of the biggest cruise liners in that industry are actually customers of ours as well. So as I wrap up, Snowball is not the only AWS Edge service that we've worked with and tested. This isn't our first rodeo. In fact, we absolutely love the AWS direction for Edge, and we're trying to march in lockstep with AWS on this. So we've proven out edge computing architectures with the other edge services from AWS, including local zones and wavelength. We're service ready certified on outposts. And we've done similar tests on these services that show similar reductions in latency for app reads and writes. So these edge services are great for our partnership because they make it easy for customers to adopt edge computing, spin up infrastructure for nearly any use case. Because everybody knows AWS, right? Or any technical team pretty much knows AWS, and they can get AWS infrastructure in their local city or on a 5G network, on-prem, or even in a small box that they can take to extremely remote areas, as we've seen. And because of our partnership with AWS, it's really easy, makes it a lot easier for our customers to get started. They can just go to the marketplace, get Couchbase, either the hosted or the self-managed. They can even knit those together and really get going. All right, so I hope you guys enjoyed the presentation. and I'm right on time. So nobody's going to miss the bar, which is